Then our human things, travel, trade and industry may lead into a emerging of diseases because of there's a high movement of people from one destination to the other destination. So infection can travel very rapidly like influenza. Then animal trade, animal farming and those things, then it can lead into prion diseases like bovine spongiform encephalopathy. Then some areas due to breakdown in public health measures like wars, refusal of vaccines, then the natural disasters can lead into a re-emerging of infections like in Gaza Strip because of the damage to the polio vaccination program. Vaccine-derived polio is emerging. And in Sri Lanka, what's happened due to vaccine hesitancy? Measles re-emerged last year. The same thing, climate change. So the vector population, especially ticks, mosquitoes, can go into new geographical locations and lead into arboviral infections. Then the other things, human made, like bioterrorisms, can lead into emerging of infections. And another thing is the silent pandemic because of irrational use of antimicrobial agents. Now antimicrobial resistance among bacteria is a huge problem. We called it silent pandemic. One day we might run out of antibiotics to come into these pathogens. So these can cause emerging and re-emerging of these new infections. So as Sri Lanka, are we ready to tackle these infectious disease outbreak again? I think we have got enough experience obtained from COVID-19 pandemic. Now we know how to handle the patients with high infections, how to handle the public health crisis. And during COVID outbreak, the COVID pandemic in Sri Lanka, the isolation facilities for those patients are improved. Our laboratory facilities improved with PCR facilities, genomic sequencing as well. And also we go back to reinforce our infection control facilities and also good health hygiene practices, hand washing, wearing masks like that. And also it pushes us to intersectorial collaboration, even we like or not. The COVID has pushed us to collaborate with other sectors. We use the PCR machines, laboratory facilities from the universities, veterinary faculties as well, and also make more One Health approach, collaboration with our colleagues in the animal sector, plant sector, and the environment, as well as the universities. So the COVID gave the direction that we can't fight it alone. So we have to collaborate, we have to coordinate with others, with the academics, the healthcare workers, also politicians, the other administrative structure as well. Because these pathogens can have no barriers. They don't care whether it's animal or human or plant or any other territory. It can jump at any time. So when it comes to prevention and control, the most important thing is early detection and identification of the emergent pathogen. If we identified it early, then we can start the prevent of the spread to the other populations. So before establishment in the community, we have to stop it. So thereby we have to detect it early. The early detection of outbreak is very important. Maybe it will help to prevent emergence of epidemics and pandemics. So if we can identify and contain into a certain locality, then other people, rest of the world will be safe. So that is, I think, one major objective of this IDEAnet project. And also, as a scientists, clinicians, we have to have some updated knowledge on ongoing infectious diseases and outbreak, because that will help to prioritize our health policies, the research topics, even the other logistics as well. And as we have to do active and passive surveillance of the pathogen identification in humans animals as well as in the environment, like wastewater surveillance. So this is one objective of our IDEAnet project as well. So we have to do passive or active surveillance. Then we can identify those pathogens early as possible. Then we have to do research on these pathogens, detection as well as the characterization. Sometimes we have to do the virulence factors, their genetic compositions, and that can lead into development of new therapeutics, vaccines, and preventive measures, even diagnostics. And also we have to improve and keep up to date with our laboratory facilities to detect these pathogens as well as the characterization of pathogens. I think our second speaker will discuss that one in detail. So for control of these emerging infections, I think we all has to be vigilant. So we has to, as a clinicians, maybe we has to identify some clusters of unusual infections or unusual features of infection, maybe quantities. Even during the research activities, you might come across with new findings, new pathogens. So we has to be vigilant. Like example, during COVID-19 pandemic, the first, I think some Chinese ENT surgeon has noted patients coming with respiratory infections in clusters. Even in Sri Lanka, before starting that Paliagoda fish market outbreak, the pharmacist has noted that the paracetamol consumption is high. So that is a clue to come into some sort of thing. The identification of these clues are very important, as same as these clues has to be communicated to the relevant health authorities promptly. You have to inform, like in Sri Lanka, to epidemiology unit. So once you detect something in your research, maybe new pathogen, like last year we identified chikungunya virus from when we are doing a febrile patient with support of Professor Andrea's project. So we detected chikungunya in a febrile patients in last November. Then we informed to the epidemiology unit the same day, because then they can go into their action. Maybe if you worried about your findings, maybe you can put it as a preprint and inform to them, and don't wait till your publication come out. Sometimes when you publish, it will take some time, the damage has already occurred. The other thing is, when you inform to these health authorities should take a actionable thing. Not put these things under the carpet. This may be an isolated incident or something like that. They has to accept these things, because these are microorganisms. Whatever we do, they can introduce into our country. It is not the failure of the government or failure of the healthcare system. Those are pathogens. We can't see those things. They can come from the airport. They can come from any other route. So we have to accept. This is reported in the country. So then at the same time, we have to start the actionable things, rather than saying this may be isolated incident, or this may be a false positive thing or something like that. So it is something we learned during COVID time as well. And always, once these outbreaks comes, allow experts to handle. Scientists, the clinicians, epidemiologists, and those people. I think during COVID, you might say there are so many experts. They don't know about the pathogen, or even what is the COVID and what is SARS-CoV-2. So allow the experts to handle these things and make proper decisions. And also, as a scientific community, we always get the correct information from the responsible authorities, and we have to take only the scientific reports, not something in the newspapers or something there with their own interprets. It can lead into a public panic, it can lead into a misinformation and mismanagement of these outbreaks. Then we have to practice the evidence-based practices and medicines, always scientifically proven things. Then we have to adhere to the published guidelines. So these guidelines are made by the experts. So maybe time to time it might change, but at that time these guidelines are made by the experts with the evidence. So you have to practice these guidelines rather than practicing your own guidelines. So it will lead into a more spread, more disaster. And always we need to be doing coordinative actions with clinicians, laboratory experts, administrators, and the other scientific fields. You can't fight these things alone. And same time, as a research community, we have to start research and development activities. We have to develop new diagnostics, new vaccines, and medications. The same time, I think I have to emphasize, we have to keep our basic laboratory techniques up to date. Because these infections, new infections, we can't rely on commercial kits. And maybe the supply chain might hamper. So we have to do something, start in-house testing and some innovative things during these outbreaks. I can remember sometimes during COVID pandemic, sometimes we run out of extraction kits. Then we go back to our basic chemical extraction methods. Like that, if you updated and if you practice these things, you can start these things during pandemics. Otherwise, everybody will forget these things. Now, most of our laboratories now using commercial kits. So they know only put this thing and get the results. But keep it basic techniques in microbiology, culture, ABST, then in-house serology assays, in-house PCRs, primer designings, and those things. Otherwise, if something happens, we can't practice in our own. Even the world, maybe world pandemic, suppliers will give these things into a higher incoming country or something, then we will run out of it. We have to keep those basic techniques, even animal inoculation test and viral isolation, cultures, we have to practice and keep it in your knowledge bank. Otherwise, we will be in trouble on those kind of situations. And during outbreak and pandemics, please do not share anything unconfirmed or incorrect information. So I think even our colleagues also put in Facebook post this, but they are incorrect. And this will lead into public panic. And also, they will lose the confidence among the scientific community. Even during COVID, this Nipah outbreak, India is going on. There are so many people shared the photos with COVID photos, during COVID pandemic photos. This is Nipah, this much of dying and those things. It will give the misinformation, and also we will lose the confidence with our public people. Then the coordinating efforts with any center, and also we have to build up the trust, reduce panic, and also transparency of information to the public. We have to tell the truth. This much of infection is going on and this is what to do. Otherwise, people will not trust us, especially the healthcare sector. And always we have to support the pandemic preparedness and facing the crisis situation, and we have to keep the priorities. Sometimes we have to sacrifice. Maybe your laboratory might has to give to the diagnostic thing at that moment, but you have to accept that and you have to support it, because during pandemics or epidemics we have to prioritize. We can't do everything. Maybe your ward, maybe your laboratory, maybe your education institute might convert into a different thing. Even our one of schools education units converted to isolation units during that time. Some wards were closed down, surgeries stopped, the planned surgeries, and those medical sources were transferred into pandemic management, like that. And we have to accept that. Don't make like unnecessary demands on those things. Support it. And always we have to practice the evidence-based and scientific things, not to promote these myths like Dhammika Paniya or Dunhattiya. No, it's funny, but if it is something happens once again, within couple of years, there will be so many things will come out again. History will repeat. So many healers, there's no scientific basis on this. There may be traditional products with scientific basis, so that is different. But there will be so many healers. Now there's a treatment, someone says HIV is available, and people go into that person. And drug resistance occurs, uncontrolled, HIV is transmitting. So those things can happen. So we should be practice only the science. We are practicing the Western science, Western medicine. So it is evidence based. And what are the lessons we learned during COVID and what way forward we are going on. So this, I think this is for most for health sector, the keep isolation facilities, rooms ready for conversion. I think now already these build up isolation facilities are now distributed to different officers, different units. Now once distributed, they make some alteration. Then it's very difficult to convert back into a isolation units. And always we has to keep personal protective equipment stocks and frequent training how to use it. Suddenly it happens, we will run out of these things if you are not in hand. Other thing is, we have to continue the good habits we learned during COVID pandemic. Our respiratory hygiene, hand hygiene. I think most of them are now it's forgotten from our life. During this is an influenza season. This time influenza is maybe bit virulent or something. It's bit bad, and the most of the respiratory cases, 90% is due to influenza. But very rarely now we see the people with respiratory infections using the mask and hand hygiene. Now everything is forgotten. So I think these good practices we have to keep going once we learn during COVID. And always we have to share our experience and we have to publish it in scientific journals. Then the other people can understand. The other people will use it as a guide for a next time. And also, we have to promote the vaccination against infectious diseases. During COVID, this was a big problem. There was anti-vaccinators emerge. And this lead into there's a different community with refusing vaccine in Sri Lanka also, lead into a measles outbreak last year. And always we do this acute and active and passive immunization, and also we have to keep good collaboration with our One Health partners. And also we doing as a researchers, we have to use appropriate personal protective equipment and containment levels in the laboratory practice as well. Think about biosafety, biosecurity as well. If those things are not in place, don't try to do so many highly pathogen things. Very recently, I evaluate the research proposal. That proposal says they are going to culture the JE virus. So JE virus is a class 3 pathogen in Sri Lanka, which need the biosafety containment. So this might lead into a disasters. And always the practice laboratory waste management. Don't dump into a normal garbage. It will lead into a pandemic process. And always adhere to the good laboratory practices and regulations as well in the country once you get down pathogens or transport the pathogens to other region. And also think about dual purpose research as well. So it might lead into disasters if you not adhere to those things. And also as community as well as scientific community, we have to promote the vaccination, because we and you all may be here because of our fathers and mothers. They practice vaccination. They gave vaccine to others. That's why there's no diphtheria, no pertussis, no tetanus. Now, some people are refusing these vaccines. Now they see only the side effects, not these infectious diseases. They say, why we are giving the vaccine to our children? So it affects the own child as well as the other children as well. Also, we have to give correct information for our health care workers as well as the general public. And we have to practice this travel medicine as well. If they recommend to take vaccines, you have to do. This is another problem. Like sometimes in Sri Lanka, we got this meningococcal outbreaks. So some people go into Hajj pilgrimage. It's a mandatory to take the vaccine before taking Saudi visa, but number of people who left is 3 or 4 times higher than the number of vaccines we imported into the country, meningococcal vaccine. So somebody has given the false certificate or false approval. So those kind of things can happen. Then other thing is, we have to use these antimicrobials also rationally. Otherwise, antimicrobial resistance might cause one day a huge threat, both bacterial and viral. Even now, Tamiflu, the oseltamivir is available in over the counter in some places. So we have to do correct things. Then it will help those emerging and re-emerging infection mitigation. So thank you.
Thank you, Dr. Rohita. Let me introduce our next speaker, Dr. Andreas. He's a scientist from the SZBS-1 Robert Koch Institute, and he is instrumental in developing new techniques and deploying them all over the world. So he gave a very nice training to some of our participants who are here already in new techniques. So that was, I think, an eye-opener in handling and introducing these techniques to communities like ours. And then he would present on rapid molecular diagnostics for emerging threats, developing field deployable tools for outbreak responses. Over to you.
Thank you so much, Inuka. Okay, so for those who don't know me, my name is Andreas Püskens. I'm from the ZBS1 at RKI. I worked there since 2020 and I had the privilege to come to Sri Lanka many times with the IDEA project. And yeah, I would just like to thank you all for that we can work together and do such amazing things. And it's always nice to be back in Sri Lanka. So today, as Inuka said, I will speak about rapid molecular diagnostics for emerging threats, developing field deployable tools for outbreak response. Sorry guys. I have to say this is really an honor to be here with such esteemed speakers, and it's an honor and it's also a little bit of daunting for me. So I hope that today I can give you guys a practical perspective of what we were doing in the laboratory from the concept to actually field deployable diagnostics. And this is especially important when trying to fight emerging infectious diseases. I think we as scientists have something of like a hive mind going on. So this wasn't orchestrated or something. So I'm using the same slide as Dr. Rohita. But I think he did such a great job at introducing all of this, so I can actually skip this part. And in this room of experts, I don't have to say it. I mean, emerging threats, they are here, they're everywhere, and they have become more and more often in recent decades than all those years before. And yeah, very prominent examples are, of course, the monkeypox outbreaks, as well as in Sri Lanka, we have a lot of dengue outbreaks, as well as the chikungunya outbreak in 2025. And as Inuka said, we basically developed a rapid test for chikungunya, brought this here to the workshop, and the participants could use it. Rapid diagnostics are a key strategic pillar in combating emerging infectious diseases, and this includes, for example, early detection and case identification. This was also mentioned before. This is really important to break transmission chains and isolate infected individuals. We have also the surveillance and monitoring, so we can use rapid diagnostics to monitor disease trends. And actually now, in the digital age, we can use those to do real-time mapping of disease spread. And this can then also inform our decisions for the deployment of medical countermeasures. So we can quickly identify cases and at-risk populations. This can inform vaccine distribution and also, of course, the deployment of therapeutics. And one part that we are very interested in is also that these rapid diagnostics can be used in resource-limited settings and also in field settings. And this enables on-site testing and also mass testing in a decentralized setting, so not in a centralized laboratory. So to get here, this has been an issue years ago. So there has been a gap because, as you can imagine, an emerging agent, especially newly emerging agent, is not part of the routine diagnostic panels that we usually have available. So we need to design these tools first. And this has been difficult for a long time, and I wanted to give a recent example with the SARS coronavirus. So in 2003, when we had the SARS-CoV original outbreak, we had actually a limited sequencing capacity, and this was in 2003, and we had also often incomplete sequences. These sequences were only gradually released, only after publication on GeneBank. You mentioned this before. And also we didn't have the infrastructure to do this great amount of data sharing. And also, as the keynote speaker mentioned yesterday, there were regulatory barriers on specimen and data sharing in place. So actually, it took us 3 to 4 months from the outbreak to a publicly available real-time PCR protocol. Fast forward to 2020. For SARS-CoV-2. Actually, the first genomic sequence was shared within 10 days of this new virus. And this is one of the greatest shifts in genomic surveillance that I think has happened in recent years, that we are now able to basically in real time sequence new viruses and then share the data. And this has been done. So we had, by October 2021, we had 4.8 million genome sequences on GISAID. These were publicly available. And these then, of course, can be used to develop new rapid diagnostics and also do the vaccine development, as we all know. And on January 13, 2020, we had the first PCR protocol available, and this took us only days. So now we are actually in a position where we can rapidly develop these diagnostic tools to combat emerging infectious diseases. So what should these rapid diagnostics be capable of? And I think this is not a small feat. And as you can see here, there were some criteria defined. Before, these were the assured criteria. You might have heard those. Now it's called reassured. And these include real-time connectivity, ease of sample collection. They should be affordable, sensitive, specific, user-friendly, rapid and robust, equipment-free, and deliverable. I think this is not a small feat for diagnostic tests. However, today I will focus on one technology that I believe fulfills all these criteria. There are many more portable and point-of-care tests available. So we have LFA technology, multiplex PCR systems, portable real-time sequencing is possible, you know, all nanopore sequencing. But today I will focus on isothermal amplification and specifically on LAMP. So why LAMP? So first, we have reached a developmental stage where we have first LAMP-based diagnostic kits available for purchase. So like a PCR kit, you can buy those now online. And also, we don't need a thermal cycler to run amplification. And this might sound small, but what it actually means is that we don't have to rely on expensive equipment that needs a lot of power. So here I just brought you some examples. So we have one device that's very tiny, so it fits in the palm of your hand. This is for just 2 samples, for example, a control and a patient sample. And this can run via USB-C, and you get the results in real time on your phone. This is also what we try to use in the workshop. So I think this was really cool to see. And also, we have a bit more sophisticated devices, still much cheaper than a thermal cycler. They can be operated with a power bank up to 12 hours. They run with 8 samples, and they have 2 fluorescence channels, so you can even run some multiplex assays on those. You can put them to a suitcase and bring them wherever you need them. LAMP also enables fast amplification. And what this means is basically you have rapid test results. So usually LAMP assays, they can be between 15 minutes to 1 hour, and they will deliver results to you. So this is faster than usual real-time PCR. They are also highly adaptable in terms of readouts. So we have a lot of options with isothermal amplification, how we can visualize these results. For example, colorimetric, so visual readout. This is something that we like to do in Berlin. So we have a colorimetric readout where you can see that the positive samples, they have shifted into the yellow, and the negative samples, they remain pink. We can, of course, do real-time fluorescence readouts, like in real-time PCR. We can use LFAs and so on. So there's a lot of different possibilities which enable us to use this in the field. And this is now very important. So LAMP assays can be designed and validated in days once the pathogen sequence is available. And as I showed you before, now we are capable of doing this. And actually for this course here, it took us a few weeks, but we managed to get a running chikungunya virus assay that we used here on clinical samples, and it worked pretty well, I would say. And the participants were actually doing it, so maybe you can later share your experience on this. So this is the ZBS1 LAMP assay portfolio. So as you know, we are virologists, so most of these are viruses, and in bold you see the emerging viral pathogens that we already designed assays for. And what I would like to focus on today is just show you two examples. One is orthopox virus detection, and the other is a dengue virus detection and typing assay. So this is work done by a student, Rebecca, back in Berlin. And so what we did is that we went into the literature and we checked different rapid detection tests and lamps for dengue virus. And what we saw is that they actually use only very few sequences to design those assays. And as you know, most of you, dengue is quite genetically diverse. So what we did is actually we went back and we went on GeneBank and we did a new design that is based on 4,277 genome sequences from almost the entire world. And we did an unbiased approach to develop these, to design these assays, which then technically should be able to run globally. And as you can see here, these are probit analyses. So here we quantified the viral RNA, and as you can see, we reach sensitivities between 96 and 734 genome equivalents per reaction. So for a screening test, this is very good. And actually, and I think this is a success story of the IDEAnet project, we had the great opportunity to join colleagues from the Department of Medical Microbiology and Immunology. So Dr. Nisha Rockwood was so kind to allow us to their lab, and their team was supportive. And we actually tested this assay on clinical samples from Sri Lanka. This is the data you can see here, and it's basically in line with what we found with cultured virus in Berlin. And unfortunately, at the time, there were no dengue 4 circulating, so we couldn't test this for dengue 4. But what you can see is that we reach also, in comparison to real-time PCR, quite good sensitivity, and there's no cross-reactivity between those assays. So again, you can use this assay for typing of dengue virus, and this is all happening within 45 minutes. So as you know, dengue is a RNA virus, so usually we have reverse transcription, and with PCR, I think this would take around 1 hour 40. So we can decrease the time. And again, we have a dual readout. We also have the colorimetric readout, which you can see here. So before the amplification, all of the media are pink. And then after amplification, after 45 minutes, the positive samples, they turn yellow. Another example I wanted to show you is our orthopox virus. We call this LAMP ion. So this is basically a combination of LAMP screening in combination with nanopore sequencing. So I will just quickly guide you through the workflow. This is for the detection of human pathogenic orthopox viruses. And what we can do here is actually when we have a patient and a lesion, we can swap this lesion and we can go with the buffer directly into a LAMP reaction. No extraction is needed. This has to do that we have a lot of virus in those lesions and there's enough free DNA to run the assay. And it's quite sensitive actually. So the extraction step can be completely omitted, which speeds things up. And then we have our LAMP reaction. This takes only 30 minutes at 65 degrees. You can do this in a water bath, in a cycler, wherever you want to do it. And then we have a dual readout. One is a fluorescence readout, like real-time PCR, what you know from the real-time PCR. And the other one is, again, the colorimetric readout. And this will tell you in 30 minutes if a person has an infection with orthopox virus. If you want to know what it is, so in a bioterrorist context, this could be variola, but for example, when you are in Africa, in the field, this might be more likely monkeypox. You can then use rapid real-time nanopore sequencing to do species identification based on those LAMP amplicons. So what we do is a rapid library preparation. This takes around 20 minutes, and then we do sequencing. And we developed a software that can actually stop the run in real time the moment we have enough data. So within 1 to 2 hours, they can actually identify if this is monkeypox or variola or cowpox. So here also some data to not just show you some nice imaginary pictures. So again, in comparison to our autopox PCR, we use at RKI, the RPO PCR, the LAMP is able to detect CT ranges, basically till the end, between 10 to 20 minutes. So this is quite good. And when we use clinical samples from suspected autopox virus infected patients, we also see that the data is in line with the PCR. So all the positive PCR samples are detected in the LAMP and all the negative samples come back negative. This is how we would like to see it. And this is then how it could look in the field, or how it looks in the field. So we have our little isothermic device there, which is running on battery. We do a screening of all the samples, and after 30 minutes, we see that all these different autopox viruses, they come back positive. And this machine also can show you this nicely on, as you can see there on this device. There's just a positive, negative, or invalid result. If you press on this button, you will see the real-time amplification curve. So this is also really nice. And then the positive samples can be pooled, rapidly barcoded. We can do 69 samples on one flow cell. This is saving time again, and we can scale this up. And then this is running, and then actually the software will call the species identification. Some current projects I want to show you. So as you know, Russia is waging a terrible war in Europe, in Ukraine, and so we in a big consortium together with other European countries will work in a project called Resilience. This is funded by the European Defence Fund, and here the goal is to develop a ruggedized system that can be used by soldiers in the field. As you know, Russia had a bioweapons program, in the Soviet Union had a bioweapons program, so we're also concerned about these things. So here we present a workflow that hopefully will enable soldiers in the field to collect samples, do rapid extraction, and then testing in the field on biothreat agents. What is nice about the system, this is kind of an open platform. Of course, this is fieldable, but it's also open source. So you are not dependent on the companies that they say, we don't want to do this assay, so we can design our own assays rapidly. There's also reagent flexibility. During COVID, we knew that the supply chains, they can collapse. So here we are not dependent on one single supplier. We can use different suppliers, different reagents. And we are now starting back in Europe to produce our own enzymes in Poland, for example. So this is really important. It's customizable to the need that you want, and this is not only in the biothreat context important. I will talk maybe later about this. So with Anka, we are also planning to bring this to Sri Lanka in more of a One Health context. And of course, it's also fairly affordable. Other current projects, we have talked about this a lot, and you might be wondering, so we also now want to integrate rapid on-site extraction protocols into our workflow, because right now we can do rapid detection, but we also need to do rapid extraction. And these are just some ideas that we're having, and this is what Anka and I are exploring currently in Berlin, and hopefully we can also bring this in the future into the IDEAnet project. Also, we develop ruggedized solutions that allow fast and simple on-site testing. So what we do in Berlin right now is that we develop a isothermal suitcase diagnostic unit. This is basically a suitcase lab. So we have a suitcase, and all these little devices that you see will be in there, and you will be able to perform this locally. Currently, also we are working on assays for Babesia. As you know, this is a problem in Sri Lanka, and the idea would be to supply vets with these suitcases. They can go to the farms, they can do the testing on the ground, they have a result on the ground, and the farmer can then treat the cattle or not. So this is a future project that Anka is leading. And so this brings me to the end. The take-home messages are that rapid diagnostics have become a key strategic pillar in the fight against emerging infectious diseases. They improve diagnostic capabilities in low resource and point-of-care settings, and LAMP offers an alternative to PCR, meeting the reassured criteria. And we have various readouts that are possible, so colorimetric, fluorescence, and sequencing, as I showed you. And LAMP-based diagnostics, they bridge speed and simplicity for rapid, rapid tests with the sensitivity and specificity of molecular tests, rendering them ideal for point-of-care applications. And with my last slide, I'd like to thank everyone involved in the project, especially the team back in Berlin. Some of them are here, Gunnar is here, And yeah, so the entire team at ZBS1 is always super helpful. So this is a big team effort. Of course, I'd like to thank Inoka and Andreas for letting me do all of these things. And yeah, of course, also to Nisha and her team for letting us come and do such nice work together. Thank you.
Thank you very much, Andreas. And our next speaker, the final speaker for this session, is Professor Saminda Fernando. So, Professor Saminda Fernando is also, I think we have a very long history. And more than 20, just like Professor Enoch Pereira, a proud alumni of our university. And now he's the professor at the Open University of Sri Lanka. And he has been working with us, with our colleagues in the field for a long time. But today he will be talking on identification of emerging agents, a zoological perspective. And let's welcome Professor Saminda. Thank you, sir.
Okay, good morning, everybody, and thank you very much, sir, for kind introduction, and thank you for inviting me to deliver this talk on identification of emerging agents, basically the zoological dimension within the One Health concept. Before that, I will briefly explain what is the One Health. Because One Health concept is an integrated approach, recognize the interconnectedness of the humans, animals, and the environment, health to achieve an optimal health outcome for all. It is not a new idea. It's basically but in modern days, it's very important because 21st century we are confront of the global changes in land use, the climate change, and also the wildlife interactions. In our ancient times, we are practicing in the One Health concept in broadly. I will give three major examples from that. The first one, I will talk on the ancient tank irrigation systems and the health, because the ancient hydrologic civilization of Sri Lanka, mainly the Anuradhapura and Polonnaruwa era, design tank cascade system we normally call the Elanga system that maintains the ecosystem balance. This system ensures the clear water for humans and animals, and also it will create the wetlands for supporting biodiversity, mainly the fish, birds and amphibians and the reptiles, and also it regulates the disease such as malaria by maintaining this ecological balance. Therefore, it reflects the One Health principle, mainly the sustainable water management for well-being of the people, animal, and the environment. Then I will give the second example is that though co-inhabiting of the human wildlife in ancient kingdom, because in the ancient times the wildlife was protected around the tanks, forests, often declare them as the sanctuaries of the king, mainly at the royal garden in Anuradhapura in time of King Tissa, 3rd century BC. It's basically this practice reduce the human wildlife conflict and protect ecosystem and sustainable clear water and air for the people and also the wildlife. Then the third important example is that religious and cultural teaching. The Buddhist philosophy emphasizes the compassion, the karuna for all the living beings. This cultural attitude towards the animal welfare, vegetarian and non-violence indirectly supports the disease prevention, and also it will gives the environment protection. Therefore, the Sri Lankan ancient civilization practiced One Health in spirit long before it was scientifically termed. Therefore, it's through basically the ecological harmony, the sustainable agriculture and respect for all life forms. Then in the modern day, the interconnected world, the ecological disruption, the climate change, and the global trade accelerate the rate of these pathogens emerge. Therefore, in instant, the studies suggest that the increase of global temperature are leading to increase the heat tolerance of fungal pathogen. For example, in the sudden appearance of the treatment resistant human infections of Candida aureus, a fungus that was previously non-pathogenic to human in multiple continents, has been accelerated with the increase of this global temperature increase. And then I will small, because the audience know everything like the emerging agents and everything, but some are not familiar with these terms. I will say the emerging agents are the pathogens which are virus, bacteria, fungi, or parasites that are newly recognized or newly evolved or have apparent after apparent control, reapparent after apparent control measures. Not only that, some of these agents can be infected new hosts, or they can spread to a new region, or they can develop a new transmission patterns. For the current world, the 70% of emerging infections are disease in humans are zoonotics. That mean they are originated from the animals, then spill over to the human. For example, in here you can see the vector-borne diseases. The 79% of these vector-borne diseases are caused by the viruses. And also in the world, the waterborne diseases, 79% of these the waterborne diseases are mainly caused by the bacterial agents. Based on the etiology of the zoonoses are classified into four, mainly the bacterial, the viral, the parasitic, and the fungal. Now, I will move on to the factors contributing these emerging zoonotic agents. I will list down in 10 points, then I will show one by one what are the main factors that these contributing of these factors for emerging diseases. The first one, the environment and ecological changes, the mainly deforestation and the habitat destruction is bring to humans, the livestock and the wildlife into a closer contact. It will facilitate the spillover these agents, and also the agricultural expansion and the land use changes. Basically, this conversion of this forest and into the farmland or the settlement increase the exposure to wildlife reservoirs. And also the loss of biodiversity is also reducing natural barriers that limit pathogen transmission. Then the other important factor as a biologist, as the zoologist, we normally call the climate change is more important phenomena, because the climate change alter the distribution of vectors, mainly the mosquito, tick distribution, and also their reservoir species. And these changes is in temperature and rainfall pattern influence the pathogen survival and replication. And also the globalization, also one of the important factor, because the international travel and the trade rapidly move infected humans, the animals, and also the products across the borders. And also the wildlife trade and market create the opportunity to cross-species transmission. For example, in this picture, you can see different animal species hosted in a similar place, and it will be created a more opportunity to cross-species transmission of these pathogen agents. And then the human demography, I think Dr. Rohit also mentioned about this one, how this population growth and urbanization increase to spread these diseases. And I will highlight something like the cultural, some countries, they have these cultural and occupational practices. They have unique the cultural and occupational practices. Those are very important. Those are contributing this zoonotic risk. And then the intensive livestock production, the high density animal farming, it's promote the pathogen amplification and mutation. And also in this intensive livestock production, we use we misuse the antibiotics, and it will create the antimicrobial resistant zoonotic bacteria. not only these human interference in the emerging of these parasitic or these agents, the parasite also has, or these agents also has some adaptation, basically the genetic mutation or recombination. For examples, I think the two speakers already mentioned about this one, the European avian H1N1 virus. This caused by the mutation of some of these virus. And then the weak public health and veterinary infrastructure also a matter from this emerging part, and also sometimes the socio-economic and the political factor also contributing this one. For example, poverty and conflict drive people to rely on the wildlife for food and for their trade. And then the global trade in wildlife trafficking is another important part, because the legal and illegal movements of the wildlife, exotic species, and also the productions, the animal productions also facilitated these transboundary spreading of these pathogens. Finally, I will tell the factor that urban-rural interface expansion. You can see the peri-urban zones increase the interaction between the domestic animals. Like here, this is the peri zone, and this is the forest, and this is the city line. This area is more prone to have the interaction between the domestic animals, the wildlife, and the human. This will create the hotspots for viral the agent spreading. Now, I think the most important part, because most of these things, the zoological dimension is not mentioned, like, because we have a big role as a zoologist, we have a big role for to help the mitigate or the prevention of these pathogenic spreading. Now now that we know that susceptibility of zoonotic conditions are is very high in the world, and what is the role of zoologists in the managing these emerging agents? Zoologists can contribute in different capacities, starting from identify the host species to wildlife monitoring and surveillance and sampling collections and taxonomical identification, and also the ecological patterns of these host species, and also the behavior and the vector ecology, and also finally we can we have a collaborative role as well in the different the health professionals. Starting from this one, the identification of host species, mainly the zoologists recognize the potential reservoirs, and also they can see the carrier species of emerging pathogens. And in this regard, we can use different parameters, like we need to see the species diversity, the population structure, and population ecology, because this is very important, that the identifying these which animals are more abundant and which animals are more widely spread, or which animals are closely associated with the humans. It's very important to mitigate these emerging diseases. And also we need to study the behavioral patterns, like different animals has a different behavioral patterns. For example, their feeding habits are different, some of the different animals, and also their migratory routes, the roosting or their nesting site. The studies will influence the pathogen exposure and the transmission. And also, as a zoologist, we can have the host parasite associated, because we need to document with host carry specific ecto-endosteinal parasite that may serve as the pathogenic vectors. For this, in the field, we use different equipments for that, mainly for the tools like camera traps. We use these camera traps for monitoring the population size, different population structures, and the diversity of these the host species. And also we can use mistnet for mistnetting, or mistnet we can use for that to capture the bats, birds, like that. And also we can use GPS collars for monitoring their movements patterns, like see their movements ecology and their roosting sites, like that. And also the acoustic monitoring part, mainly we use back detectors. For these, we can use for the detection of the night dwelling bats. For example, the current we conduct collaborative research work with Professor Inoka, Dr. Pipulayapa, and Professor Andreas, and it's basically we have a project I think the Chamara will showcase their research work. In this research work, we normally the landscape contents of the roosting site, taxonomy status of the moving ecology of Pteropus medium, our Sri Lankan flying fox in Sri Lanka. In here we use GPS collars, and this data will use for future the virus spreading research in Sri Lanka. And also as a zoologist, we collect different biological materials such as blood, saliva, fecal samples, and ectoparasites for pathogenic screening and genetic analysis. And these are two ongoing undergraduate research projects which different objective, not directly related to the identification of these emerging agents. But interestingly, we found malaria parasite in some of these bat species. It's a wild one. Currently, we are working to confirm the species level. And not only this one, we also conduct some research, basic research, like see how the host parasitic interactions of bats, mainly the ectoparasites, and also some of these brown palm sweat cat civets, the endoparasite surveys, and also some collaboration with the veterinary faculty in the Peradeniya. We conducted some morphological and molecular taxonomy of some of the gastrointestinal parasites in elephants in Sri Lanka. And not only that, because as a zoologist, we need to taxonomically identify or systematically confirm the host species. Therefore, because if the misidentification of the species, it can be led to incorrect assumption about the disease ecology or transmission pathway. Therefore, both morphological and molecular methods are used to ensure the correct identification of these reservoirs or the vector species. This is one of the example from this one, because I think most of the zoologists know that it's very difficult to identify the rattus species. It's because we use the only colors, and their tail length is mostly to differentiate these rat species. But in this study, we develop a database for phylogenetic database. It will be helpful for identifying the particular species for this rat one. And also, not only that, we also do ecological and behavioral studies, because we need to know about how habitat disturbance or climate change and food availability influence the animal movements and the contact with the human. And also, we need to know about how migratory birds or the bat colonies move pathogens across the regions or in different borders. And also, we need to know about the seasonality and reproductive cycles of the host that may affect the infection rates and the spillover. And this is another example that we conduct effect of research on the effects of urbanization on zoonotic gastrointestinal parasite prevalence in the endemic torque macaque species. And this study, we sample 180 macaques individual. It gives us 61% of these macaque species are infected in one or more the parasitic stages, and some of these parasitic stages are zoonotic parasites. Therefore, this indicates the anthropologic activities which lead to urbanization, and also increase the parasitic infection among the torque macaque species and well as the human population. And then as we the zoologists, we can do the vector ecology and arthropod studies, basically the species compositions and the distribution of these vectors, mainly the mosquitoes, the ticks and other vector species. And also we can study the vector feeding preferences and also we can study the environment conditions that favor vector breeding or pathogenic transmission. And these are some of the examples that already we concluded. Like, this is my undergraduate project. It's basically study the ectoparasite of reptiles at the National Zoological Garden. These tick species are novel to Sri Lanka. And also this is the ongoing research work. Basically the ectoparasite of selected chiropteran species. It's an ongoing one. Most probably we have a lot of information regarding this the ectoparasite part as well. And then the finally, what is our role for as a collaborator in the One Health framework? The role of zoologists in this collaborative work, including providing ecological interpretations of epidemiological data, and also we can advise on wildlife sampling, and also designing and site selection, and also we can contribute to early warning systems by identify the ecological changes or unusual wildlife mortality events that could indicate the pathogen emergence. And also this integration allows the timely detections of the emerging agents and enable the public health authorities to act before widespread outbreaks. And these are the major resources that we are working on, these emerging things, mainly the bats, rodents, birds, and the primates. And then what is our future direction as a zoologist? Because when we consider about our surveillance studies in Sri Lanka, it's very lacking. Therefore, we need to expand the wildlife disease surveillance in Sri Lanka, and also use new techniques for monitoring the pathogenic conditions, for example using the environment DNA for pathogen monitoring part. And also we can use different promote the community-based wildlife health monitoring system using the different the remote sensing techniques, and also different AI technologies used for that. And also we can integrate conservation and public health policies, because in our policies we don't have the conservation and the public health is together, like sorry. Therefore, we need to incorporate the conservation of the wild animals and the animals, and also to ensure the public health as well. Therefore, these are my collaborative research institutes. We work on these institutes, and also the most of the studies I have highlighted here are done with these collaboration with these researchers. And I happily say that all of them are my university teachers, and I would like to extend my sincere gratitude to them before I wrap up this talk. Thank you very much.
Thank you, Professor Saminder. Can I invite the speakers and the chairs to the stage? All right, so a big thank you to our distinguished speakers. Before we open the forum for the audience to ask questions, let me ask just an opening question from Dr. Andreas. I was just wondering, when you divulge all the methods that you do in terms of introducing these techniques for identifying threats, especially in war times, right? So we would actually see some novel smart pathogens maybe appearing, because now all the old techniques might be already out there for those who design weapons to be kind of go around them. So do you have a comment on that?
Yeah, that's a good question, I would say. As Dr. Rita already said, that I think we shouldn't forget the old techniques, and it doesn't mean that when we have new techniques that this is not solving everything. And for example, PCR is such a brilliant technique, and if you can use PCR, you should use it. So for example, these LAMP tests, they're meant to be bridging a gap bridging a gap for moments when we don't have the capability to go to a centralized laboratory and do our proper testing. And as you said, when with the automatic extraction kits, I remember as a student to doing phenol, triazole extraction. I think it's very important to keep the knowledge alive, how to do these things. With the pathogens, so there is a threat for new pathogens that being developed as weapons, I would say. That's in the times of AI and stuff, this is things we are concerned about. But again, we should also not forget about the old threats. For example, variola virus. Professor Nietzsche is expert on pox viruses. So back then, everyone was vaccinated. Now, not everyone is vaccinated anymore. Introducing this back to a population would be a big, big problem. And we need to be prepared for the new things, but also for the old. So yeah, we cannot let our eye from the ball, let's say.
So may I ask one question from Dr. Rohit? And you mentioned about Gambika Panier, and also maybe I got it wrong that traditional medicine is kind of not effective. But in Sri Lanka, especially my generation, so we in fact believe have faith on traditional practices, and to a certain extent it's proven that they are effective. So when you said that traditional medicine is not effective, because I knew even during COVID time some people resort to using kottamalli and other decoctions made in home, and they claim that's also to a certain extent effective. So would you like to comment on that?
Sir, you have just misunderstood. I said that traditional methods, it's okay. We can do the research and do it. But something people who develop this, like exotic, this kind of a thing, those kind of things, they don't know. Even they don't give what is the composition of inside that. So those kind of things can appear and it can do the harm. But the traditional things, maybe there's a truth on it. These are like opportunistic people who develop something and trying to earn something and disrupt our thing. The traditional things, that's fine if it is effective.
Thank you.
Professor Samit actually started off with giving a very nice overview on the things that we did way past in our times, in the ancient times, how to keep these pathogens at bay. How do you actually take this message to the current conservation practices so that we can have a more harmonious way of doing things?
Actually, because currently the sustainability part is not in our system, like, because we talk about the sustainability, but practical scenario, it's not practically we are not practice that one. That's why the most of the wildlife conflicts are there. The most of the human and wildlife conflicts mitigation measures are not very good for that, because those kind of things maybe we can increase the awareness of the people, and well as the ancient things, what kind of sustainable the human and animal interface, what kind of sustainable and what kind of health promoting systems are there. Those kind of things we need to educate the people, and also we can practice those things. I think that's the main thing we can start from this part.
Thank you, Professor Samit. Shall we open the floor to the audience to ask some questions? Yes.
Good morning. I am Deepthi Vikramasinghe from the Department of Zoology and Environment Sciences. I have a question to the Health Ministry official. As we all know, we have many pets at home, right? Especially the young children, school children, or the kids. They don't know how to handle pets in a safer way. There could be many contaminations, and they could be very vulnerable to zoonotic diseases. Does the ministry have any kind of program to educate these young children or even the adults at home to handle the pets safely?
Yes, actually for pet handling, we have the health education programs, especially for responsible pet ownership. I think in future it might come as a law as well, but currently our Health Education Bureau and the Public Health Veterinary Service also, they do the education for keeping these pets. Now these days we having a problem with the rabies as well, and we advise how to vaccinate these animals and also handling the sick animal as well.
I'm Nirmali Pallewatha. This question is mostly to Saminder and maybe Vipula also, because you two are the only ecologists, in my view, on this panel. Okay, Saminder, number one. See, now when you talked about this impact of environmental, yesterday it was only the Secretary of Health who talked about, he said, if you meddle with the environment, then, he went on to say you are basically asking for problems like zoonotic diseases. I think that's because he was the former Secretary of the Ministry of Environment also, right? So he has been educated, if I may put it that way. No offense meant to the medical professionals here, right? Please. Saminder, do you have any data that shows you habitat fragmentation or degradation, there are different ways of measuring that, has a connection to the prevalence or, well, I'm not sure quite how to put this, but the potential or probability of jumping to the human population. Do you have?
Yes, madam. Actually, some of these macaque studies, macaque population studies, we study the urbanization effects of these macaque species. Basically, we collected some samples from the rural areas, the sub-rural and the urbanized areas, the macaque those samples, we got some zoonotic potential parasite present there. And isolatedly, there are several studies is there, madam, but it's not mainly, we are not focusing the habitat destructions and everything. But normally we say, oh, this study we only recorded the zoonotic diseases like that, not only related with the other part like environment part. Because it's basically because yesterday the secretary said definitely that's because we are not consider about the environment, we are only consider about the health and the animals only. That's the thing, madam. But we have some good examples from to highlight that fragmentation effects and everything, madam.
Thank you. That's very important because I have another question which may be relevant to Vipula also. With these, now. See, I saw your collaborators were wildlife department, etc., right? I don't know if there's anybody here, but what Sri Lanka has enough policies. Problem is that they have not been translated into action, right? No, not enforced through action. Now that last bullet point that you said about taking this forward requires the environment, the policymakers. By this I don't mean politicians, I mean the Ministry of Environment, right? Because they are the overall thing, and the Department of Wildlife Conservation and the Forest Department and CEA, mostly on land, to recognize what you have found. I hope you publish them because I'm asking you because of another reason. That's another time to explain that. But I really hope that you would be able to show them, because what is lacking in the One Health approach in Sri Lanka, right, is the environment, the real natural environment aspects are missing. So I'm happy to see that you're doing this, but I really hope you manage to take this forward, right? And not, keep it as a publication. Thank you.
So that's a very important question, Nirmali. So in fact, even yesterday the secretary mentioned that. So you also know about the study that even in the university system or within the university, our collaboration with other people are very, very, very weak. Right? That's one reason, and also this is the first time, more or less, I have seen that medical professionals are working closely with the what we call the non-medical scientists. Yeah, yeah. So that is one of the very most inspiring thing for me. Participating in this conference in IDEAnet, where the scientists, I mean, of course, there are scientists from the medical profession also, but science faculty people are working with the medical faculties. So that's one very good thing. But when you go outside, we don't see such a collaboration even between Department of Wildlife and Forest Department or Department of Irrigation and universities. We are all work in isolation. So, but I think let's hope that this is the beginning, and in years to come, under this One Health approach, that we all can work together. So, which is very important.
Okay, I have a question from both Professor Samind and Dr. Rohit. Years ago, we wanted to do a project on rabies in the wildlife animals. But we couldn't do it because we had to culture the brain material to get the virus. So those days, so with the scientists who are working in the wildlife department, we wanted to do this, but we couldn't do it. But now there are newer techniques without brain culturing. Now you can do it. So is there a possibility of monitoring the wild animals for rabies?
Yes, currently it's available. So the wildlife, Department of Wildlife, if they found some animals in their facilities, they submit the samples to the rabies laboratories for testing. So we do the antigen testing and the PCR on those samples. In Sri Lanka, the problem is not the wildlife actually, mainly our domestic dogs and the maybe semi-domestic free-roaming dogs are the rabies reservoir in the country. So there is a risk of these infection can go back into the symbiotic cycle. So they are monitoring under the rabies control program.
I think yes, that because mainly the wildlife department, they found some carcasses, mainly the jackal ones. They sent to these samples to VRI and also the MRI for testing these virus things. Other than that, because no evidence on it, no things.
Question for Dr. Andreas. Apart from your beautiful, elegant lamp assays, can you comment on feasibility for developing antigen IgM-based lateral flow immunoassays for our setting for important pathogens?
Yeah. So in terms of the LFAs, you mean for antibodies like in the blood or for antigen LFAs? Yeah, I mean, we know during COVID that they had a tremendous importance in fighting the pandemic. I think the deployment of the antigen test was really important to control infection. So at ZBS1, we are normally focusing on nucleic acid detection, but you can use LFAs. You can include a probe into the primer design from the LAMP assay, for example biotin, and then capture that probe with an antibody on an LFA. So then you have the readout of a rapid test, but you're still detecting nucleic acids. So we are not working on the antibody or antigen detection as of now, but I think, I mean, you're much more closer to the clinics. I think they are highly important and they should be deployed and they should be developed. Absolutely.
May I add probably something? And this goes out to you, Andreas, as well to Dr. Rita. In the high-income countries, we do see that especially the acceptance of point-of-care testing due to quality, due to sensitivity is always, let's say, challenged from strong labs, call it like this. How would you emphasize the acceptance when hearing about these wonderful techniques and possibilities? Is there the acceptance or the willingness in Sri Lanka, from your perspective, to create even more probably point-of-care assays for Sri Lanka?
Now, point-of-care testing is rapidly getting popular in Sri Lanka as well, especially not only for infectious diseases, even for biochemistry and hematology as well. But the thing is, we have to select appropriate kits for the appropriate diseases. So as a screening test, sometimes it's okay, depending on the sensitivity specificity. But as a confirmatory test, we might go for a definite confirmation test as well. But it's depending on the disease. So like dengue maybe as a screening test is okay. But if you're going for like a rabies, it is life-threatening disease to check for the host animal, then screening test is not acceptable. And also in Sri Lanka, the whole test should be registered. The commercial assays should be registered in our regulatory authority. So they check for the sensitivity, specificity, as well as the utility of this test. So depending on those things, we regulate it as well. So, but it's become very popular as a bedside test. But also depending on the disease, depending on the acceptability, we have to interpret it also very carefully as well. Sometimes false negative results might end up in a disaster. That gives a false sense of security and things as well.
May I ask, can you hear me? A question to Dr. Rohita. Would you say that the acceptance of vaccinations in Sri Lanka is generally high and you have a lack of vaccines? Or would you expect that, like in Germany, vaccines are available, but people are somehow reluctant to get vaccinated? What would you think is the situation in Sri Lanka?
Sri Lanka, we have the expanded program of immunization, which is even free for all healthcare, small children, as well as the private sector also doing. So there's no inadequacy of the vaccine supply. And we had a very good vaccination program and coverage almost like 99 to 100%. But unfortunately, in last couple of years, there's a certain fragment of groups, which is extremes of certain religions, as bit of propaganda for refusing the vaccines. Like in Germany, they have so many reasons to tell. So our health administrators and epidemiology unit is tackling with them. But unfortunately, those groups are really extremism. So even they don't under control for their religious leaders as well.
Okay. So, but maybe if it's of help, even Edward Jenner had to fight anti-vaxxers already 200 years ago. I was hoping we have developed since 1796, but maybe some have not. Thank you.
I just have a comment. Actually, you touched upon climate change. I think climate change plays an important dual role in those kind of diseases because, as you correctly mentioned, it increases the range of vectors plus the emergence of new pathogens. At the same time, it suppresses the natural predators of these vectors as well. So both contribute to spread of these diseases in an uncontrollable way. So it plays a real important role, I think.
All right,
This
so in
is
the absence of any
actually
other
to
questions,
Dr.
to
Andres.
wind up. Yes, please go ahead.
This is to Dr. Andres. Yes, it is important to identify either positive or negative with the qualitative identification. And is there a way to quantify the amounts the viruses are present with the lamp, as it is very important with the patients like kidney diseases who transplanted
Yeah.
after got this infected with this virus infection?
I will rephrase the question. So you asked if it's able to quantify with LAMP. So yeah, I think I didn't mention this specifically, but with the LAMP, as it is shown here, it's more like a qualitative test, right? It's a yes or a no. It's not like a real-time PCR with a standard where you can do actual quantification. However, there have been now efforts on a digital LAMP. So as you know, there's digital PCR, which we can use to do the copy number, so the quantification of nucleic acids or viral copies. This is what we did there with these probit analyses, where we show how many copies can still be detected. This is possible with LAMP as well. And there's very nice applications where people bring this onto like a cover slide for like a microscope, and they run the reaction in a type of a gel, and then the gel solidifies, and then they heat it up, and inside the LAMP reaction is running, and you get little foci of fluorescence which you can count with a little microscope or with a other device, and from there you can then quantify. So it is possible with LAMP, but not based on the technology we use here. This is more like a qualitative yes or no. But it's a very interesting topic, yes.
All right, thank you for that question. So with this, yes, please go ahead.
I'm Tushara Dantirige, Chief MLT Medical Research Institute, Parasitology. I just want to thank you, all of you, for collaborating all of us. This is a real need. I think Professor Shaminda has done so many researches which is related to us. We were even don't know. Bertiella also, we have found recently the world longest Bertiella, but we don't know you have done researches on it. Because I would be very glad and gratitude for this team.
All right, so I think the last comment was the best to sum up this session, because it's the collaborations that we don't have the communication that is what's hampering some of these initiatives that we take. So let me finally thank the speakers and wind up this session.
I kindly request all the speakers and the chairs to remain on stage. This invitation goes out to Professor Vipula B. Yapa and Professor I.C. Pereira to present the tokens of appreciation to our speakers for session 1. Dear ladies and gentlemen, please give a big round of applause as we present the tokens of appreciation to the speakers of the first session, Dr. Rohita Mutugala, Dr. Andreas Pruskins, and Professor Saminda Fernando. I would also like to invite up on stage Professor Andreas Nish to present the tokens of appreciation to the chairs of the session. Ladies and gentlemen, please give a big round of applause to the chairs of session 1 for that very informative and engaging session. Thank you very much. Thank you very much, session chairs and the speakers, for that very engaging and very informative discussion. Now we will be moving on to the flash talks by our young researchers and PhD students who will be given the opportunity to briefly present their work. My first invitation goes out to Ms. Hansi Ganheva, who will be talking on the title Analysis Virome of Aedes mosquitoes.
So good morning all, I'm Hansi and today I'm here to present an overview of my research topic, analysis of the virome of Aedes species in Sri Lanka. So moving to the introduction, vector-borne diseases affect approximately 30% of the world population. So in particular, these viral pathogens transmitted to humans by insects are of major concern due to their increase in their incidence and rapid geographical distribution. About 300 types of mosquitoes efficiently transmit arboviruses to the community, posing a great threat to humanity. So among them, these Aedes species play a key role. So as we all know, these Aedes species mosquitoes play as vectors of several diseases including dengue, chikungunya, yellow fever and Zika viruses. But recent reports suggest that these mosquitoes can also act as vectors of several other viruses including Ross River virus, Japanese encephalitis virus, West Nile virus, Powassan virus and etc. So with the light of the above, the general of my research is to evaluate the virome of Aedes species mosquitoes in different localities in Sri Lanka and the corresponding disease prevalence in associated human subjects, whereas specific objectives are to evaluate the viral diversity and prevalence among each Aedes species in Sri Lanka, to identify vulnerable populations for arboviral infections, and to investigate the relationship between habitat dynamic and the virome of Aedes species. So moving to the methodology, so mosquito samples were collected from 7 sites out of the 9 proposed sites in Sri Lanka using an improved Procopac aspirator, and the collected mosquitoes were morphologically identified up to species level using standard taxonomic keys. Then the samples were pooled and homogenized and the viral RNA was extracted using viral RNA minikit. The extracted viral RNA was used for metagenomic analysis, cell culture work to determine the transmission status of the viruses, and for detection of arboviruses by RT-PCR assays using the developed arboviral panel. In the second phase of the study, it involves investigating the serotypes present in suspected dengue patients. So for that, 250 serum samples were collected and viral RNA was extracted, and the extracted RNA will be used to identify infective dengue serotypes using RT-PCR assays, and dengue negative samples will also be analyzed by the arboviral panel. So this is an ongoing research, so I will present some of the preliminary results of the study. So figure number 1 shows the number of Aedes species mosquitoes collected for different sampling sites, and a multiplex RT-PCR assay and 4 singleplex assays were developed and optimized to detect 4 arboviral pathogens including dengue, chikungunya, Zika and yellow fever viruses. Development and optimization of the singleplex assays will be published in the future. And in context of viral diversity and prevalence among mosquito species, 117 pooled mosquito samples were tested, viral RNA was extracted, and samples were screened for 18S rRNA mosquito housekeeping gene, and arbovirus detection was conducted by RT-PCR singleplex assays. None of the samples that I tested out of the 117 samples didn't get positive for dengue, chikungunya, Zika, and yellow fever viruses. So in clinical sample analysis, 250 samples were collected, and so far 70 samples were analyzed and samples were extracted and screened for the arboviruses. Out of the analyzed samples, 27 PCR positive samples were there and 43 PCR negative samples were there. So in conclusion, mosquito surveillance continued. So the species collected were Aedes aegypti, Aedes albopictus, Culex species and armchair species. So all the mosquito pools were screened via RT-PCR for dengue, chikungunya, Zika and yellow fever viruses, and all pools were tested negative. This might be due to low transmission activity, seasonal variation, and effective vector control, or else collecting timing outside of the pre-transmission. For clinical surveillance, 250 serum samples were collected from dengue suspected patients. Among the first 70 samples tested, 39% were dengue positive, whereas 61% were dengue negative. So this is an ongoing research. So mosquito surveillance from selected localities is continued to evaluate the viral diversity and prevalence, and also testing for the remaining clinical samples and collection of samples is in progress, which will help to correlate entomological and clinical findings. So this is the end of my presentation. Thank you very much.
Next, we have Vithusha A. Rambamurthy on the title, Decoding the Pathogen Landscape of Selected Rodents in Sri Lanka. Good morning, everyone. I am Vithusha A. Rambamurthy. Today, I am happy to present my ongoing research work on decoding the pathogen landscape and zoonotic potential of selected rodents reservoirs in Sri Lanka in an integrative one-health perspective. Moving to the small introduction part, as we all know, emerging and re-emerging infectious disease continue to threaten global health, with the over 60% being zoonotic in origin. As we all know already, the rodents act as a major reservoir host, having circulating pathogens among them. In Sri Lanka, the repeated outbreaks of leptospirosis and the typhus underscored the nation's vulnerability as a hotspot for rodent-borne diseases. The rapid urbanization, global growth, environmental changes, population growth, and inadequate public health system further support these risks. With the recent global resurgence of orthopoxviruses, there is growing concern that the novel foxvirus may also be circulating in wild rodent population. Adopting an integrated One Health perspective, this study aims to decode the pathogen landscape and zoonotic potential of selected rodent reservoirs in Sri Lanka through comprehensive molecular and serological method. My research general objective is to decoding the pathogen landscape and zoonotic potential of selected rodent reservoirs in Sri Lanka in an integrated One Health perspective. And to achieve this major goal, we divided into 6 different specific objectives. The first specific objective is to identify selected rodent species using morphological and molecular markers for accurate taxonomic classification. The second one is to describe the virome of selected rodents in Sri Lanka. And third one is to identify potentially zoonotic pathogens circulating among selected rodent species in Sri Lanka, and to detect foxviruses in selected rodent species using serological and molecular method, and also to detect and identify gastrointestinal parasites present in fecal samples through microscopic examination and molecular characterization based on 18S and 28S ribosomal rDNA sequencing. And also we are planning to detect pathogenic leptospira from selected rodent species. Here you can see this is our work in a nutshell. Here I mentioned about the serological and molecular screening of case zoonosis. In the first material phase, we have used first we get all the permits from Wildlife Conservation Department and the ethical clearance from IOBSL to handling the rodent samples and to take the samples from different mammalian zones of Sri Lanka. And for the rodent collection is still ongoing, and also we are identifying rodents using several standard books morphologically and willing to do taxonomic identification also. And when we are doing sampling, we are following all the personal protective equipments, and when we are sampling, all sets of comprehensive collection of blood, urine, oral and anal swab and fecal ectoparasite samples are collecting. Still the sample is ongoing. When it comes to the methodology, I have used the standard protocols set by the RKA SOPs. First, I did all the samples were inactivated. This is the workflow for the inactivation of sample. Then for the subset of samples which collected from the Sri Lanka, we did indirect immunofluorescence assay to check the seroprevalence of the foxviruses. And third, I did the real-time PCR assay for genus-specific Leptospira PCR and also FANFOX PCR assay. After this, when we discuss about the results and analysis and also the discussion part, first set of samples were tested for the indirect immunofluorescence assay. In this, out of 50 samples, 3 saw some considerable amount of inclusion body in up to 4 titers, and 2 samples show that seroreactive, it's little bit the inclusion body for 2 samples. These are the curves of the Leptospira PCR. Out of 75 samples tested, we got 4 samples positive for Leptospira. This is the genus-specific Leptospira, but we are planning to do sequencing to check the serover or strain of this Leptospira. This is the overview of the molecular and microscopic landscape of rodent parasite. This is the materials we use to collect the fecal sample for the molecular and morphological analysis. These 2 methods I have used, the direct saline and iodine methods and also the centrifugation method. And then after collection of sample, the samples were analyzed for morphological analysis. I have found out of 50 samples tested for microscopic analysis of the GI parasite, nearly 50%, half of the animals show the parasite positive for gastrointestinal parasite. Then those samples were tested with the molecular analysis, NGS sequencing analysis. I checked with I pulled the samples and I checked with 6 pairs of different 18S primers and 2 pairs of different 28 primers, and check all the pools with all 8 primer pairs, and all sample pools were show the bands. But in the morphological analysis, I could able to found 50% of the sample show the positive for GI parasite. And I did the NGS analysis, but the still analysis is ongoing. As a conclusion, a foundational data baseline was created, the fox virus. We generated initial baseline data on fox virus exposure from the first subset of samples indicating preliminary serological reactivity, and also confirmed the presence of Leptospira species in 4 out of 75 initial tested sample, confirming active infection early in the study, and also confirmed widespread circulation of diverse parasites via microscopy and successful molecular amplification in tested subset with rare sequencing data already generated. And also we extracted nucleic acid subset of sample from multiple samples type belonging to initial 75 individual rats are stored at RKA ready for metagenomic analysis. Thank you. And as the final speaker for session 1, we have Anne Catherine Desh on the title of Improving One Health Diagnostics in the Biodiversity Hotspots, Sri Lanka.
Hi everyone, so who does not know me, I'm Anka. I'm also one of the PhD students in the project, and I also have the honor to give a flash talk today about my topic, which is called Enhancing One Health Diagnostics in the Biodiversity Hotspot Sri Lanka. And so why do we need infectious disease diagnostics? As we already learned yesterday, Sri Lanka is called to be a diversity hotspot. So there's a lot of wildlife going on, and not only Sri Lankans, but also tourists get in close contact with this wildlife, which can then lead to spillover events, as we also learned today. And because of that, we need animal and vector screening to prevent those transmission routes. And for that, we would like to implement rapid, sensitive, and specific on-site testing. And I think everyone kind of knows this graph. So what's my work actually doing? So I have 3 parts in my thesis, and they're all kind of linked, but also separate. First of all, I do the sampling. Use the elephants and cattle. We have the extraction, which is the bottleneck of those things, and we have the LAMP methods, where Andy Piskin's already told quite a lot today. So first, I start with the sampling. You already saw that we have not only elephants that we sample in the project, we also have different animals, but I focus mainly on elephants, which I'm really happy about because, as you might know or not know, I'm a veterinarian. So for me, this was really special to be able to sample elephants. We do not have them running around freely in Germany, so this is the difference. And yeah, I visited 3 different sites here in Sri Lanka. So we went to the Dihivala Zoo, we went to Pinavala Orphanage, and also, I'm sorry to pronounce it incorrectly, but Udavaleve Transit Home. With that, we were able to sample 80 individuals, and we collected not only oral swabs, but also nasal, or actually it's their trunk, but trunk sounds a bit weird, so we go with nasal. Also their feces, urine, and if possible, blood. So how do we approach those samples? We start with an open view diagnostic. So we give those samples to NGS, mainly Illumina sequencing. Some of those samples are right now there, so we're waiting for results. We also do cell culture to be able to screen and identify those relevant or emergent pathogens. And if we do find something, then we test back with PCR or also LAMP if possible. We design those, and yes. And Andreas already mentioned some of this stuff today. So we're also working on a suitcase-based laboratory where we can, just give vets the suitcase in the field to be able to detect not only viruses, but also bacteria or parasites. So we came up with a workflow because it's not that easy to find the perfect rapid extraction method, right? So we just looked online what are kits already out there, and we tried to find those that fit our criteria, so which are cheap, fast, and don't need a lot of material or equipment. Because in the field, we don't want to have a heating block or like a centrifuge that's not really adaptable. And then we thought, okay, how do we test this? We need some reference or some model viruses, and we chose the pox virus, which is a DNA virus and has an outer membrane. And we also choose an RNA virus where we went with the feline Callice virus because it's also both BSL-2 laboratory, so we don't need to go in the BSL-3 lab. And then we also need a reference again because we cannot just say this kit works well or not. We use a QIAGENE DNA blood kit or the RNA viral kit. I think most of you are familiar with those kits. We also use them in the workshop. But as you all know, those are expensive, they need a lot of material, and they take quite a lot of time. And we don't have that in the field. So Andy P. and I went in and thought, okay, what kind of sample material can we test? And we are our own donors, so all these sample materials are from us, but we just spike them then with the those pathogens, with those 2 viruses, and then we have a certain dilution series, so we can really test back at the end what is coming out of the kit. And last but not least, we have the LAMP again. We already heard again, we design our own assays, but we also check the literature, so what is already out there. And if we find something, we see if they fit our criteria again, so do they work with our standards? And if yes, we just order them, and we also design our own assays and have a little proof of principle if they even work or not. If they do, we go further and also check the specificity, so we just check that in silico and also in vitro, so whatever pathogens we have, we just check if they work. Then we have the sensitivity. So as soon as we have candidates that are working, we go in and try to see the limit of detection. And if we did find finally our best assay, we go back and just try to optimize it as best as possible. And also, which is really important again for the vets, we go in and the feasibility test. So do they work in the field? Can they be read out colorimetrically or whatever is applicable? And which is probably now the most important thing or the interesting part. What assays are we working on right now? We have the Mycobacterium volvus one. This is already, this list already IDP talked about, but this one is mostly done. It just needs some feasibility testing. We have the Leptospira one, which is also almost done. We're just waiting for sequencing data. And last but not least, I'm working right now on the Babesia one. And hopefully more to come soon. So this is it. And if you ever ask yourself how you work in the field and sample elephants, it's quite chaotic. Sharaka was with me. This is how it looks. And thank you to everyone.
Thank you, Hansi, Vithusha, and Anne for sharing your research knowledge with us. And with that being said, we come to the end of session 1, in which we dug deep into the theme of our session, identification of emerging agents. Now, it's time to move on to session 2. Theme: Diagnostics and Public Health. Accurate, rapid, and accessible diagnostics are the backbone of infectious disease control. This session explores diagnostic innovations and their link to public health action. Chairing session 2, we have Professor Andreas Nische and Dr. Gaini Premavansa. Dr. Andreas is the head of the Division of Highly Pathogenic Viruses at the Robert Koch Institute and the driving force behind IDEANet from Germany. And as our second chair, we have Dr. Gaini Premavansa, a medical practitioner who was instrumental in starting this collaboration back in 2017. While she was at North Teaching Hospital, Ragama, she was a key in the IDEANet project. Dr. Premavansa brings clinical and public health perspectives, bridging laboratory diagnostics with patient care. This request goes out to our session chairs, Professor Dr. Andreas Nische and Dr. Gaini Premavansa, to lead the session.
Good morning. Dean and co-chair, Professor Andreas, and Chair Dr. Premavansa, Professor Inokasi Pereira, and distinguished guests, professors, lecturers, students, ladies and gentlemen. It is a privilege and honor to address the IDEAnet Health Forums 2025, jointly organized by the University of Colombo and Robert Koch Institutions, Germany. This gathering brings together scientists, clinicians, researchers, and public health professionals, and also medical administrators, policymakers, who share a unified vision to extend diagnostic capacity and foster collaborations for tackling emerging and re-emerging infectious disease. Diagnostics form the cornerstone of public health practice. They transform clinical suspicions into evidence and guide interventions that save lives. In the continuum of public health, diagnostics serves as bridge between patient care and populational level prevention. Accurate and timely diagnosis enable early outbreaks detections, case confirmations, pathogens characterizations, and evidence-based decision making. From hospital to field surveillance, every data point generated through diagnostic contribute to a clear picture of disease dynamics. To strengthen a nation's health system depend on the reliability, quality, and accessibility of its diagnostic infrastructure. Diagnostic system in Sri Lanka. Over the past decades, Sri Lanka has made a significant strides in building and modernizing its diagnostic and laboratory system. The National Influenza Center at Medical Research Institute and several teaching hospital laboratories now house advanced molecular diagnostic platform, including real-time PCR and sequencing facilities. Guided by the Ministry of Health and supported by the WHO, Robert Koch Institute, and international partners, the country has developed a tiered national laboratory network integrating molecular diagnostics, AMR surveillance, and outbreak response mechanism. During the COVID-19 pandemic, Sri Lanka rapidly expanded its real-time PCR testing capacity from a handful of institutions. Over 25 public health public sector laboratories, demonstrating resilience, adaptability, and intersectoral coordination. This network has now evolved into the foundation for ongoing molecular surveillance of emerging and re-emerging pathogens. Emerging and re-emerging diseases. Recent experiences with dengue, chikungunya, Nipah, and COVID-19 have underscored a critical lesson. There is infectious disease now, no boundaries. Modern molecular diagnostic enables real-time cross-sectional detections of pathogens at the human, animal, and environmental interface. The introduction of field deployable molecular tools like LAMP assay and internal quality control systems strengthens our preparedness, that is biosafety measures, for future zoonotic and vector-borne outbreaks. Sri Lankans perceptions in global genomic surveillance initiatives like influenza surveillance also enhance our ability to track pathogens evaluation and antimicrobial resistance trend. Our One Health approach, the One Health approach integrating human, animal, and environmental health provides most comprehensive framework for surveillance and control. It will support cross-sectional early warning and response, diagnostic collaboration across public health, veterinary, environmental labs, with the partnerships, the Department of Animal Production and Health Unit, Epidemiology Unit of Ministry of Health, universities, and IDEAnet will strengthen the system, I believe. Capacity building and quality assurance. Sustained diagnostic capacity requires investments in people, quality, and system. Over the years, Sri Lanka has focused on training laboratory professionals, developing standard operational procedures, and implementing external quality assessment scheme. Workshop like IDEAnet, with the support of Robert Koch Institution, Robert Koch Institution collaboration, play a pivotal role in equipping our scientists with the latest diagnosis technique, biosafety practices, and quality assurance tools. Going forward, priorities include strengthening a national laboratory network with defined referral and reporting pathways, expanding molecular diagnostic platform beyond central facilities to regional laboratories, integrating laboratory data with public health intelligence system, and ensuring sustainable financing and maintenance for diagnostic infrastructure. That is very, very important for Sri Lanka. Diagnostic beyond laboratory. Diagnostic extend far beyond laboratory walls. Interpretation, communication, and translation of diagnostic results into public health actions are equally vital, whether guiding clinical management, vector control, or community interventions. Diagnostic intelligence drives decision making. Emerging innovation such as digital data platform, artificial intelligence assisted interpretations, portable sequencing tools, and point-of-care molecular devices are redefining the diagnostic landscape. These technologies promise faster, decentralized, and more equitable access to diagnostic service, especially in remote and resource-limited settings. To ensure diagnostic remains at the core public health action, Sri Lanka continues to emphasize policy alignment, intersectoral collaboration, and evidence-driven decision making. The establishment of national laboratory policy and integration of laboratory governance into public health programs demonstrate this commitment. Strengthening links between clinical laboratories, veterinary institutions, and environmental monitoring will further enhance One Health surveillance ecosystem. Regional and international collaboration such as WHO, CRO, IDEAnet network are crucial to sharing data, standardization methods, and building collective preparedness against cross-border health threats. Strengthen national lab network and referral pathways, expand molecular platform to regional level, integrate laboratory data with field surveillance, ensure financial and operational sustainability, foster regional collaboration through the IDEAnet WHO CRO. I believe that the way forward, very essential areas. As we step into new era marked by climate change, globalization, and emerging pathogens, diagnostics remain our first line defense and our strongest instrument of prevention. Sri Lanka, actually ours, progress illustrates that through collaborations, innovations, and sustained investment in people and systems, we can achieve resilience and responsive diagnostic network. Let us continue to turn diagnostic data into public health intelligence and results into resilience, ensuring that every laboratory effort contributes to safer, healthier future for all. Before conclude, I acknowledge Ministry of Health and Mass Media of Sri Lanka, medical research institutions, our epidemiology unit, WHO, RKI, IDEAnet, and Fleming Fund, university partners, and laboratory professionals and professionals and laboratory colleagues. And I need to thank my consultant committee physician, Dr. Hamza and team, assisting me to prepare this small presentation. I am not the speaker, I am the lecturer, I am an administrator. I don't have ability to talk more. Therefore, I think you will not ask question from me. Thank you very much for giving this opportunity.
Now we're coming to the second speaker of the session, which is Dr. Janine Michel. Janine is working in RKI since 17 years now. She started with a practical course like an internship, and now she is deputy head of the division highly pathogenic viruses. She is a real expert in diagnostics. She was traveling for WHO several times throughout the world, supporting establishment of labs, and she is a kind of our diagnostic knowledge base. And I like to say, if I talk about Janine, I like to say one thing. I think she is the only scientist in our whole group who was able to do any step of SARS-CoV-2 diagnostics on her own, starting from accepting samples, printing barcodes, doing extractions, PCRs, analyzing the data. So she knows everything, and she will present just a little snapshot of what we or she is doing and talk about pox viruses. Maybe someone heard that we like pox viruses somehow, and this is what she is showing now, some news in the diagnostics. Thank you.
Thank you very much for the kind introduction and having the opportunity to speak at the first One Health Forum of the IDEAnet. And as Professor Andreas mentioned, I'll speak on the possibilities and challenges in poxvirus serology. And just as a short remark in the beginning, I present this data on behalf of a whole group, so this is not my data alone, obviously. So we do have the reference laboratory for poxviruses. That's why we are interested in poxviruses quite a lot. So to give you an idea of pox viruses today or before 2022, there's different pox viruses that are present in the world. In Europe, it's mainly cowpox viruses that we can find. In India, it's the buffalo pox virus. Usually in Africa, mpox virus could be found. And there was small outbreaks in the United States of America. Vaccinia virus can also be found in Americas. In South America, it's the Vaccinia-like viruses, but there's also parapox viruses and molluscum contagiosum virus, which also belong to the pox viruses. So this was before 2022, and in 2022, mpox basically spread all over the world. Mpox virus is a typical orthopox virus. When we talk about the size, the shape, and the genome, it can be differentiated into two genetic clades, clade 1, which was found in the Congo Basin, and clade 2, which was present in the West African area. Its natural host, it's rodents or maybe sometimes squirrels, and we were able to get isolates from there, but non-human primates, it's not so sure if these are natural hosts, but they have turned seropositive. Humans are actually accidental hosts, but we can obtain isolates from humans as well. So the question was, did we ignore mpox in times of smallpox because it was sort of covered up when smallpox was still present in the world? So the mpox or monkeypox virus situation today is, you can see it has mainly spread all over the world with the different clades that can be detected in the different areas. It is very small, but basically this figure is supposed to show you that the virus can be found basically everywhere. Here is a little table with the total case numbers, and as mentioned before, in 2022, it hit basically a lot countries in the world with over 80,000 cases detected in more than 100 countries. And as of this year, so far we have detected about 44,000 cases all over the world in 93 countries. For the clinical diagnosis of mpox in 2022, you have the lesions are usually circumscribed, deep-seated, and umbilicated. They have the same size and the same stage of development when you look at the same single side of a body. For example, if you have lesions in the face, they usually have the same size and same stage. You may also have lesions on the leg, and they may have a different size, a different stage. Usually there is a fever before a rash. Then you can identify a lymphadenopathy. The rash that is present is usually centrifugal, and the lesions can be detected usually on the palms and the soles. The lesions itself can be painful until they become crusts, and the incubation time is a very short time, by about 2 days. But people can get a rash first, followed by other symptoms, and others experience a rash only. And the diagnostics is usually done by PCR of the lesions. There's a vaccine available now, which is called the Imvanex or Genius, depending on the part of the country, the world that you are located in. It is based on a modified Vaccinia Ankara. It is a highly attenuated live vaccine, which is replication deficient, and usually 2 doses are needed to induce an efficient immune response. And since it's a full virus, basically, it induces the immune response against multiple target proteins of the virus. But it helped to bring the mpox under control. And maybe you have heard of Edward Jenner. He was the one to basically establish the vaccination for pox viruses, and this led to the eradication of smallpox virus in 1980s. So to come back to the situation in Germany, basically, and I mentioned before, we are the consultant laboratory for pox viruses. Before mpox, the situation was, as shown here on the left side of the picture, we had about 30 to 80 cases per year with about 50 to 300 samples. There was not that much work to be done, but then 2022 came and the situation changed completely. Since then, we have basically a lot of samples every day, but in 2022 it was a lot, and we had over 6,800 samples from about 3,000 patients that we had to analyze. And since then, we have analyzed more than 8,000 samples from more than 4,000 patients, and about 1,300 of those samples were supposed to be analyzed by serology, which is the main topic of my talk. So serology, there's different methods that can be applied for serology. First of all, there is the immunofluorescence assay. Here you will need 2 consecutive samples, basically, with a difference in sampling about 2 to 3 weeks, which would be good. Then there's ELISA methods, and then the plaque reduction neutralization assay, which can be applied. Orthopox viruses are known to be highly cross-reactive. The targets of neutralization are not really known, but they exist, and we have different proteins that we have to consider when we think about the different forms that the viruses can form, and I will come to this on the next slide. The correlate of protection is not known. Animal experiments for this would have to be done to find this out. So like in other tests, when you have a unit, for example, for SARS-CoV-2, when you can say like with the unit of, I don't know, 100 units per milliliter, you will have protection or whatever. This is not known for pox viruses. So far, there's only a few commercial kits available, and to be honest, they were not pretty good. So as mentioned before, there's different particle forms of orthopox viruses. We have the intracellular mature virus, or short IMV. They're responsible for cell lysis or cell-to-cell infection, and these proteins listed here are usually found on the cell surface or on the viral surface of these viruses. Then we have the extracellular enveloped virus. They are necessary to spread in the system, and they have different proteins that are then present on the viral particles. And here you see an electron microscopic graph of the different virus forms that are present or that can be formed, the mature variants, and here the extracellular enveloped viruses. So what have we done? We have explored the possibilities of how to perform serology under different biological safety conditions. And because not every laboratory in the world, or not every, laboratory has a BSL-3 laboratory, the idea was to see if different serological assays or different assays can be performed under different biological safety standards. And we have explored this and have also published this, and the experimental setup was as follows. We had a panel of 16 sera from Mpox positive patients, cowpox positive patients, and MVA vaccinated people. Then we have performed an immunofluorescence assay for IgM and IgG with these sera, and have prepared slides which were infected with monkeypox virus, cowpox virus, or vaccinia virus. And as well, we have performed neutralization assays to detect neutralizing antibodies. And in the upper row, you can see the graph for the IgG antibodies, and in the lower row, you can see the graph for the IgM antibodies. In the first row, it's always the Mpox virus, then cowpox and vaccinia sera, basically. And to make it very short, basically for IgG, you can use whatever virus in whichever constellation to detect the antibodies. For IgM, it looks a little bit different, but this is mainly due to the non-presence sometimes of the IgM antibodies in the serum samples. For the neutralization test, again, we have performed the different assays with the different sera, here for the Mpox sera, here for the cowpox sera, and here for the vaccinia virus sera. And what you can also see is like all tests basically sort of work, and with the little difference of that not all cowpox virus sera did show neutralizing antibodies when applied to the Mpox neutralization assay or the vaccinia virus neutralization assay. But what we wanted to show in this case is that basically you can apply the neutralization assay in the BSL-3 setting when you use monkeypox virus, but also you can do this in the BSL-2 setting when you use vaccinia virus. There are still open research questions that need to be answered. And one of the questions was, well, how many unrecognized infections have occurred? Are asymptomatic breakthrough infections possible after vaccination? And is there an ongoing unrecognized circulation? And many, many more questions. These questions could be addressed by a serological assay with the ability to discern the humoral immune response after infection from vaccination. And before this was not possible, we have basically developed the first test that is able to differentiate vaccination from natural occurring infection. This is at the moment a preprint, but finally it has been accepted for publication after a long review process. And it will be published shortly. So to come to the assay, it is called a Luminex-based assay. How does it work? We do have paramagnetic beads which have different colors, and they can, here, basically the beads are shown here, and they can be combined after they have been coupled with their respective target protein. And so you have a highly multiplex assay that you can then read out after you have done the appropriate incubation with the respective serum and secondary antibodies. And the detection at the end is basically by the color and by the signal that will be produced through the incubation with secondary antibodies. Just a brief description of the whole process. This slide shows the antigens that have been used in this work, and we have used homologs of vaccinia virus and mpox virus that are on the surface of the different variants that I have shown before. Then there's the A-type inclusion protein that can be used to differentiate childhood vaccination from MVA vaccination. Then we have used a whole cell lysate from vaccinia virus infected cells and as well controls. And at the end, we had a 19-plex assay. So again, highly multiplexed assay in this case. So the study design was to answer the question of can we quantify IgG and IgM responses in different panels. So we did have an acute panel, which included non-infected and non-immunized serum from pre-outbreak and not within the risk population. Then we had sera from MVA vaccinated persons that were healthy subjects, and these were pre-outbreak again and also not from the risk population, so the probability that these people had been really infected was quite low. And these people had 1 or 2 shots of the respective vaccine. And then as the third group, we had mpox virus infected people. They were all PCR positive, and the samples were taken shortly after symptom onset, maximum 33 days after the onset. And then we have tested this as well with a so-called epidemiological panel, and the epidemiological study was in the MSM population, which are at high risk of infection. So in this case, we did have also non-infected and non-immunized sera from persons that had not known to have been infected in the past, but asymptomatic infections could be possible. Then we had, again, MVA vaccinated sera, so people that knew that they were vaccinated. And then, again, we had people that were infected, all again PCR positive, and samples taken shortly after symptom onset. So, and this is the part where you should not ask me too many questions because I don't know this myself. The colleagues have done this, but just to summarize this in a little bit, different methods have been applied, and ML in this case stands for machine learning. Machine learning models have been applied to train and test the different models to at the end get a prediction of a certain sample is positive and then suspected to be vaccinated or naturally infected. And this is a long process, and again, as I said, I don't understand all of this, so I cannot tell you a lot of details to these, but the key findings is that the performance of the assay depends on the machine learning algorithm that was used and the panels that were used for the training and the testing, and the models that have been trained and tested on those panels, which are called all, basically gave very high promising results with F1 scores above 0.8. So and the key findings is we have identified crucial antigens for differentiation. For example, the cowpox virus RTN antigen, which is a homologue of the mpox virus A27L protein, is a marker for acute infection, and this is possible because this protein is missing in the MVA vaccine. Then the MPXV E8L protein is highly immunogenic, so we give high titers basically, but it cannot be used for differentiation. And at the end, the overall ratio of the different antigens can also be used to get an idea if the person had been infected or if the person had been vaccinated. And then, if you want to further improve the classification, the linear discriminant analysis could be used, and at the end, you had better correlation of data. And then at some point, it was possible that you may have a misclassification of childhood vaccination via previous vaccination, and this could be addressed by changing the algorithm using the LDA approach. And again, don't ask me details about these figures because I don't understand them myself. Then we have performed this assay on a large epidemiological study from sera from Berlin, and it is called Seroprevalence Study Indicates a High Proportion of Clinically Undiagnosed MPXV Infection in Men who have sex with men in Berlin, Germany. So what we have found that orthopox virus antibodies are detectable after a monkeypox virus infection, after vaccination, after childhood vaccination, and in any combination of these. Not all MVA vaccinations result in detectable antibodies for orthopox viruses, but orthopox virus antibodies can be detected in study participants below the age of 50 without the history of any mpox diagnosis or MVA vaccination, suggesting that they had a clinically undiagnosed MPXV infection in the past. The most undiagnosed MPXV infections were suspected among the study participants with a subsequent MVA vaccination because this group was suspected to be the high exposure group. However, we cannot differentiate if a person had first been infected and then vaccinated or vaccinated first and then infected. This is the only differentiation, basically, that we are not able to perform. And of course, as we all know, undiagnosed infections are likely to play a major role in virus dissemination in outbreak situations, and that's why we would like to detect these infections early. So to sum up, different serological assays are available. I have told you about the immunofluorescence assay. I have not told you about the ELISA, but this is still available, the neutralization assay, and then this highly multiplex assay. And depending on the question that you would like to answer, the correct test should be applied. The immunofluorescence assay and the neutralization assay are for low throughput samples. So if you only have a low amount of samples, then these assays would be the choice. If you have a high load of samples that you would like to analyze, you could go for the ELISA assay or for the multiplex assay. And of course, if you want to differentiate, has a person been infected or has it been vaccinated, then you can apply this new assay that we have developed. And with this, I come back to my title. So all these assays pose or give the possibilities and challenges. Yeah, so depending on the assay that you want to use, you can use the cross-reactivity of the sera and orthopox viruses as a possibility or as a challenge. I have showed you that the detection of monkeypox virus antibodies is possible in the BSL-2 settings if you use the correct combination of a virus and sera. Basically, the multiplex assay can differentiate between vaccination and MPXV infection, and we have an underreporting of monkeypox virus infection in MSM community in Berlin. And with that, I would like to thank all the people that were involved. I hope I haven't forgotten anyone, and if you have any questions, I'm happy to answer them. Thank you.
Thank you for the kind introduction. And still good morning. 1 minute more to 12. The session chair, my overseas training supervisor, Prof. Andreas, and co-chair, Dr. Gayani, distinguished professors, lecturers, colleagues, and the students. It is an honor to speak at the IDEAnet One Health Forum 2025, jointly organized by the University of Colombo with Robert Koch Institute. Today, I will explore how diagnostics and public health from unified system for disease prevention, control, and preparedness. First, what is diagnostic? Diagnostic refers to the tools and processes we use to identify the cause or presence of a disease, whether it is in individual, communities, or the environment. It supports clinical decisions and importantly give public health system the evidence needed for policy, prevention, and action. And what is public health? According to Hutchison's in 1988 reference, public health based on the is the science and art of prevention of disease and promoting health through organized efforts of society. Its focus is population level protection through surveillance, sanitation, prevention, and health policy. When we see the evolution of diagnostic development, diagnostics have evolved from simple observation to advanced precision tools. In ancient times, healers relied on symptoms, pulse, and appearance for diagnosis. The 19th century introduced scientific foundation with the microscope, stethoscope, and the study of pathology. The 20th century saw rise of laboratory medicine. And previous speakers mentioned about all types of diagnostics. It is widely ranged, used to detect, monitor, and understand disaster, forming the backbone of modern healthcare. And it includes all increasingly artificial intelligence as well as digital tools to enhance accurate diagnosis and access. Now we come to how diagnostics and public health connect. Diagnostic and public health are two sides of the same coin. One provides the evidence and the other drives the action. Diagnostics tell us what is happening and the public health decide what to do about it. And diagnostic and public health are inseparable. Diagnostic turn uncertainty into evidence and public health transform that evidence into action. That is a connection between diagnostic and public health. The recent example is during COVID-19, Sri Lanka's RT-PCR expansion enabled precise case detection and surveillance guiding control measures. Together, diagnostic and public health form the evidence to public action. This is exploring the world of pathogen diagnostic of public health. And we come to the history of diagnostic and public health. In the ancient times, diagnosis relied on observing symptoms like fever, pulse, urine color, and Hippocrates emphasized clinical observation while civilizations such as Egypt, Greece, China, and India documented disease pattern. Public health revolved around sanitation, and the Romans, they saw the sewer system in early examples of health. During the germ theory era, the 19th century users in the germ theory and Van Leeuwenhoek, Robert Koch, and Pasteur demonstrate microorganism causes disease. And Robert Koch, the memory of Robert Koch Institute, he is the one methods for culturing bacteria laid to groundwork for the laboratory medicine with the identifiable pathogens, and public health became targeted through water sanitation and other public health measures. Once the germs were identified, public health shifted to general sanitation to targeted disease control. Here, the urban health reforms in Europe, clean water, waste disposal, that reduce cholera and typhoid. And vaccines also come to the place. The early 20th century saw rapid growth in bacteriology and virology, and standardized microscopy and culture methods improved detection. Serological test and Wassermann test for syphilis emerged, and the public health departments established laboratories and immunization programs in their institutions. And after the World War II, diagnostic advanced rapidly. Antibiotics demanded precise pathogen identification. And the ELISA, PCR revolutionized microscopy. During this time, WHO founding in 1948 introduced global surveillance networks, making laboratory confirmation as an essential for eradication campaigns such as smallpox and polio. Now come to this antimicrobial development. This particular diagnostic guide the treatment. When we diagnose the particular pathogens, the antimicrobial development also ensure cure. Together they safeguard public health. And in 21st century, molecular diagnostic and genomic surveillance transform detection. This real-time PCR sequencing and CRISPR-based method enable rapid, accurate results. Genomic monitoring allows tracking of variants and transmission chains, while integrated digital platforms strengthen pandemic preparedness. Now we focus on the public health in Sri Lanka. As the world history, Sri Lanka also early focused on sanitation, malaria, and smallpox control. And after that, establishment of a medical research institute in Colombo during 19th century strengthened diagnostic capacity. And establishment of National Notifiable Disease Surveillance System, that is the foundation of national surveillance, and communicable disease surveillance also established. Sri Lanka's surveillance system integrates clinical data, laboratory confirmation, and field epidemiology. Molecular diagnostic capacity has expanded across hospitals with the collaboration of WHO, FAO, and Robert Koch Institute, including this IDEAnet project initiative. Strengthened cross-sector surveillance and information sharing under One Health. This is some milestone in Sri Lankan public health surveillance program. And previous speakers talk widely around One Health framework. The One Health framework recognizes that human, animal, and environment health are interdependent. Integrated surveillance and collaboration among human, veterinary, and environment labs enable early zoonotic diagnostic and AMR tracking. Now, our unit as a national focal point for combating antimicrobial resistance, we are closely work with other sectors, Department of Animal Production and Health, and Environment Ministry and Ministry of Fisheries. We are closely collaborate working, and coming 14 we have the national event for One Health AMR program this month. And effective diagnostic and safe transport are central to protecting human, animal, and environmental health under One Health approach. Strong biosafety and biosecurity systems safeguard laboratories and prevent accidental or intentional release of microbes. For this, as a One Health, Ministry of Health with other One Health stakeholders, we have prepared the national guideline for safe transport of infectious substance and associated materials. The publication is on progress. This is based on the international standard with the WHO guidelines. All the laboratories in Sri Lanka can use this guideline for the biological sample transport. Now I come to the role of laboratory diagnostic and data and integration. Laboratory diagnostic data are essential for patient care, disease surveillance, and public health action Integrated data system enable timely detection, response, and evidence-based decision making, strengthening surveillance and One Health approach. Human capital and collaborations are very important. A skilled workforce is vital for strong diagnostic and surveillance. I have to thank at this point IDEAnet project drives training, collaboration, and capacity building, and ongoing investment ensures sustained capacity and retention in our, including our health ministry laboratory staff. Through IDEAnet, Sri Lanka strengthened diagnostic capacity. And for the future directions, the future of diagnostic and public health lies on integration and innovation and intelligence. Rapid point of care, digital diagnostic will enable real-time diagnosis, disease detection, surveillance, and bridging the gap between clinical care and public health response. In addition, artificial intelligence and genomic sequence and data sharings are very important to collaborate and run from outbreak prediction and control supporting precision public health action. And it will strengthen One Health framework. And as conclusion, as I told, as we are working as One Health, academia involvement with the Ministry of Health and other sectors are little less. As we are doing working close with medical faculties all over Sri Lanka, but other faculties like science faculties, still we need to have good collaboration with other scientists also. And the conclusion, I should say, diagnostic connect the laboratory bench to the policymaker's desk. Accessible integrated diagnostic are vital for disease prevention and control. As Sri Lanka advances its One Health framework, each diagnostic improvement strengthens our collective preparedness. And this point, I want to thank our ministry officials, University of Colombo, especially Professor Inoka Pereira, and IDEAnet project, and my foreign training supervisor with the colleagues. And thank you for you all, for your patience and for your attention. Thank you very much.
Thank you very much. Can you hear me? Okay. I think we can summarize that diagnostic is a very important tool in public health. And before we open the discussion to you, Gayani, or the people in the audience, I would like to ask a question to Dr. Hamza. Is okay? So if you would have to write down 3 points which would help to enable the Sri Lankan public health system to make even better use of the tools you have. So how to, you were presenting like the situation, but what could you think of doing to connect the different parts even better? It's not only to have the method established and you have the patients anyway, but what might be the steps? Our project, we are trying to implement diagnostic tools but this is only such a small part of things that may be done. What would you propose to do in the near future?
And what I feel is still we are having a lot of patients are dying in ICUs and with the probable cause of suspected encephalitis like that. But we didn't have definite diagnosis for that. I think if we are collaborating with unknown diagnosis for the first, we can take some patients are dying in the ICUs, we can get some samples, and for that samples we can analyze the gene sequences, whether it is the virus we are undiagnosed, undetected. We need to have some collaboration with that sort of things. That is my first issue. We are not getting the samples to analyze deeply into the gene sequencing level. Just we are giving the clinical probable clinical diagnosis as a virus. We don't know the sequence. And I think that is best thing to detect using the ICU surveillance, mainly for the unknown cause of death patients. We have to take the samples and we have to detect what is the actual pathogens in it. That is one thing I should say. Thank you.
Communication and getting samples to the correct place is very, very difficult sometimes, because it's very difficult to get the samples and send the samples from the ICUs to the main lab is a problem. So we always find that problem. Once we sent some samples to Germany, and there were some positive cases also. Some undiagnosed encephalitis samples. We sent about 5-6 samples to your lab once upon a time. Yes. So there's a quick communication gap here.
So I think at least it's what we offered, but sending samples regularly to Germany for diagnosis is probably not what you want to have in the future. And so it's like a coincidence, and we didn't discuss this before, Hamza, I promise, or we promise, but there might be a PhD dealing with this question in the next funding phase. On a serological basis, on NGS, on specific detection tools around encephalitis cases. You will hopefully find time to discuss it with Professor Inoka.
And my question to Dr. Atapattu, even though you don't ask us to not to ask any questions, because when are you going to send proper MLTs to our labs actually? That is
So simple answer is after recruit to the Ministry of Health, we will send it.
we are
So issues with the recruitments. Yeah, issues with the recruitments. Once recruit to the absorb into the ministry, we will disseminate. We will send MLTs to your institution. But you know the reason, no?
Yeah,
there is
I
issue.
know.
Yeah, human resources are very, very important. So if you don't have enough MLTs, the one method is who is retired can get their services on contract basis.
Because Ragama is of course inactivated because of this problem.
Yeah. If any MLTs who retired willing to join with us, we can absorb them on contract basis.
To whom to discuss the
So through the director of your hospital, send it to us. I will recommend it to our respective branch, and they will send it to the PSC with the approval of PSC. Okay, you can get it. Yeah, it is in the provisions of it is in the e-code provisions. It is e-code provisions. So how many specialists who retired also?
We can do that.
You know how many specialists now already we are getting service on contract basis.
Yeah, I know from the clinical staff, but I don't know whether the ML.
We can. And then your questions, I need to add. So policy-wise, we have a policy, but policy implementation is the issue. So we should have a solid guidelines and also familiarize with the clinicians to send the sample in the correct time to the correct place. We will do it in future.
Next question is to Janine. You know how long this vaccination persists effectively in the body? Is it lifelong, or is there any idea about that?
Well, for the
Vaccination.
I know. For the childhood vaccination, we know that we can still detect antibodies, but for the mpox vaccination, I'm not sure how long it will persist. I mean, we have done some follow-up studies, and I think up to 1 year, maybe, we can definitely detect, but I'm not sure if we have samples that we have taken like 2 years later or lifelong. Obviously, is not possible to answer yet because the vaccinations have just started, but maybe Andreas wants to add.
May I add something? From smallpox, we know that people vaccinated. No, from smallpox, we know that people that survived smallpox have been the best protected ones. The previous vaccines, the first and second generation vaccines we used, are protecting. You are going down with antibodies over time, but as a kind of Murphy's Law, you lose most of the neutralizing antibodies. So you may have a titer, but they may not protect you perfectly. And for example, we know that the last person died from smallpox by a lab accident was vaccinated. So you don't get a full or sterile protection immunity anyway by this vaccination. As Janine said, with this MVA-based vaccines, we don't use them long enough to say how long they will protect, but at least we say, because you need 2 shots with MVA-based vaccines, the one is giving you immunity, and the second one is giving you like longevity of the immunity. And this is what we have to observe in the near future. These vaccines that are used now, and I stop after the sentence, I like pox viruses, they have been used in the 70s as a pre-vaccine to reduce the adverse effects you get by the replicator in first generation vaccines, you know, so they have never been observed in a way how they protect from infection, but more how they protect from adverse effects by the vaccines. And therefore we have no experience, and we will probably gain these data now over the near future with this mpox. Are there questions from the audience? Pipula.
So I would bet that there are pox viruses in Sri Lanka. There are cowpox-like viruses circulating in Asia, in Europe, in wildlife, in rodents, and any kind of wildlife they can infect. We see this in Europe only the zoos. So this is why we started the study, also to check maybe in elephants. It may happen there. For mpox, I discussed with Dr. Gayani already. I will check the WHO data, but there have been 2 reported cases from Sri Lanka in 2022. This is what I have in mind. Thank you. I believe that due to the fact that this 2022 outbreak was mainly happening in men having sex with men, that there is a huge rate of underreporting, because it's somehow stigmatizing, and therefore I think that in at least many countries of the world we don't know the real numbers. For example, in the beginning Russia had not even 1 case, and this is very likely what no one believes. But so it's a question of how to deal with this. Is this answering your question? Yeah. More questions to the speakers, maybe?
Campaign, and we had monkeypox cases, as Professor Andreas told, the sexually transmitted ones, and even last week we had one from North Colombo. So in your presentation I saw there were many cases, many samples you have checked. As a percentage, what about the percentage of cases which came from the sexually transmitted disease clinics of patients?
Okay, so the samples that we receive in our laboratory are usually from the respective community. So usually they are sexually transmitted. Plus, since we are the reference laboratory for pox viruses, we do get a lot of already known positive samples that are supposed to be differentiated for the clades. Yeah, because then we are asked if it's clade 1 or clade 2. But if I had to say percentages, I would probably say 99%. If that answers your question.
Yes.
Maybe we can add that we are living in Berlin, and Berlin is a very huge city which is very open-minded for different ways of living. So we have probably let's say, a non-representative rate in our area in general. And more question, but we can discuss it during the break. You can somehow tell by the clade what the probable transmission rate was. So with clade 2B, was the one in this, let's say, MSM outbreak. And if you follow the news now, there's this clade 1B, not 2B. 1B is now like coming up in Central Africa, and people were afraid that this is combining the transmissibility of the 2B clade with the pathogenicity or virulence of the 1A clade. And therefore, it would be very helpful if you can type the clades. Then you will get an idea of what the origin of this virus is. And if you don't have the tools, contact Professor Inoka. I don't know where he is. And we provide you with the PCRs to do the typing.
This is regarding the, you talk about that monkeypox testing. The neutralization is also not, says that not good, and the commercial kits are also controversial. I'm asking, what is the gold standard of testing?
For diagnostics?
Yeah.
Well, the gold standard for testing would still be the PCR, basically. Because once patients have lesions, you can swab them and then you check by PCR if it is positive for orthopoxviruses or directly for mpox.
On. Okay, Dr. Janine, may I ask a question? Okay.
Yes, I look at present, yes. Not the business. I just want to know that if they are living in the enclosure, there are periodic taking on this. So there's no such a sustainable mechanism, but there are something happens if there is an outbreak with the involvement of FDA unit and other preventative sectors. We are doing some small surveillance, and if we detect any case, then we do the active surveillance. No, there is no sustainable routine methodology because lack of healthy staff into prison settings. We are unable to continue the sustainable surveillance system.
I want to add to that one. I was worked in Colombo Municipal Council 10 years back. During that period, we are doing the routine surveillance that Velikada prison is under CMC, Colombo Municipal Council. Usually, we are doing the surveillance if some cases are reported. That is under the purview of Colombo Municipal Council. Yeah. Colombo Municipal Council have different laboratories on their own that go under the local government. They are routinely doing the test in their labs. That is, other than our government sector tied specific laboratory labs, there are separate labs for the municipal council.
There are no labs with results except there's a there's a there's a prison with the support of ICRC established a lab there. But after a fire, there was incidents. So, and also we wanted to introduce a screening mechanism on admissions. We introduced some small forms and also introduced some screening tests before getting to the prison. But it is not happening. It is not continuing.
So I focus this to Dr. Janine. So are these serological testings, are they equally capable of detecting the asymptomatic carriers as well as the positive ones, the symptomatic ones?
You mean for the serological
Serological
assay, right?
testings.
So, well, once antibodies are present, then of course you can detect them, and that's the whole purpose, that you may detect later on if someone had a previous mpox infection or not. That is, yeah, basically the assay is intended to identify undiagnosed mpox infections, basically. So yes.
So was there a difference between the viremia, or do they equally contribute to the transmission, the asymptomatic ones?
I'm not sure if I understand your question.
I mean, the asymptomatic carriers, do they equally contribute to the transmission, the monkeypox carriers, asymptomatic ones?
Sorry. So first of all, I doubt that there are asymptomatic infections. It's not typical. Each pox virus infection gives you symptoms. What I know that there have been publications, but honestly, I doubt this. Because in particular, in this MSM setting, you have, how to say it carefully, you don't know where the lesions might be. And you can, it's maybe not simply visible on the skin, but there will be some kind of skin infection leading to immune reaction and antibodies. This is my personal opinion, even without seeing the lesions. And therefore, it's a typical pox infection. You get the lesions, you do PCR. If you miss the lesions or whatever you have as skin disease, then you do serology. Yeah.
No, excuse me. I just have a request. Could you please extend this course, extend this program to parasitology section also, infectious diseases? No, this kind of program. Because they yesterday when I asked from Genius German panel, they have said it is only to virology. Yeah, they are only concerning about virus.
Yes, so when we started the program or our collaboration, we were mainly focused on viruses because we are a virology division. We implemented more and more assays also for bacteria that are used in the RTI. And for specific requests, we could also ask our colleagues from the fungal and parasite section. They are also running reference laboratories and will be able to provide us with assays, but it should be at least in the first line restricted to PCR because we try to stay in the same system we are establishing.
Yes, in parasites also PCR. We are going to start Toxoplasma PCR or Leishmania PCR.
Yeah.
Thank you.
So we will hopefully soon summarize the questions that were asked to us during the workshop and during this conference, and give you a kind of brief summary and the answers to your questions. And one answer will always be, if you have specific requests, approach Professor Inoka and his group, and then we will check what we can support you with and in which way we do it, if we need a workshop or if it's just another essay.
Thank you, sir.
More than welcome. Any more questions? If not, we thank the speakers and everyone for this fruitful discussion. And I have no idea about the agenda, Inoka. Now we have some break. Oh, your agenda. Thanks.
And thank you very much for that very insightful panel discussion. I would kindly request all the speakers and the chairs to remain on stage as we are about to distribute the tokens of appreciation. This invitation goes out to the chairs of Session 2, Professor Andreas Nische and Dr. Gaini Premavansa, to hand over the tokens of appreciation to our guest speakers. Ladies and gentlemen, please put your hands together as we offer the tokens of appreciation to our guest speakers today, Dr. P. Athapattu, Dr. Jenny Michelle, and Dr. J. Hamsanande. Thank you very much. And this invitation goes out to Professor I.C. Pereira to hand over the tokens of appreciation to the chairs of this session. Ladies and gentlemen, please give a big round of applause to the chairs of this session, Dr. Andreas Nische and Dr. Gaini Premavansa, for their contributions. Thank you very much. Ladies and gentlemen, as we concluded the discussion for our second session, now we will be moving on to the flash talks. Our first speaker will be Upeksha Vanigaratna on the title, Evaluating the Combined Effects of Multiple Viral Factors on Endothelial Dysfunction and Vascular Permeability in Dengue Infections.
Good afternoon, everyone. I'm Upeksha. I'm so honored to have this opportunity to share with you a brief of my project on assessment of selected viral and host factors contributing to endothelial dysfunction and permeability in dengue infection. When moving on to the introduction part, I will not go into detail what dengue is, as I believe everyone in here will already know about this. So I will talk about the factors that contributes to disease severity in dengue infection and plasma leakage. According to the previous findings, there are several factors that contributes to disease severity in dengue infection. So I have listed out few of these factors, few of these findings in this slide, and according to these findings, NS1 significantly correlates with viremia level, and it is known to activate immune cells through toll-like receptors, leading to release pro-inflammatory cytokines and disruption of endothelial cell integrity. And according to some contradictory findings, NS1 itself can trigger vascular leakage without production of inflammatory cytokines, and it can directly damage endothelial glycocalyx components by production of enzymes. And when we are talking about the serotypes, severity depends on the infecting serotype according to some studies. But according to another set of studies, severity does not depend on the infecting serotype or immune status, but with the viremia level. And serotype linked with dengue hemorrhagic fever differs in different countries and different regions. When it comes to secondary infection with different serotype, the antibodies from primary infection can makes the disease more severe disease. When we are talking about the host responses, like vascular endothelial growth factor, VEGF, and vascular endothelial growth factor receptors, VEGFR, dengue can enhance the surface VEGFR2 expression and VEGF responsiveness while inhibiting the soluble VEGFR2 production. And soluble VEGFR2 levels decline with viral load. As you can see, there are several factors that contributes to disease severity and blood vessel leakage in dengue infection. So most of the studies has analyzed about these factors individually or few factors together. And there, you can see there are a lot of mixed and contradictory findings. So through this study, through our project, we will address that research gap by assessing viral factors such as dengue NS1, viremia, and dengue serotypes, and host factors like dengue IgM, IgG antibodies, enzymes which mediated endothelial glycocalyx degradation, and VEGF and SVGFR. Our research question is how previously mentioned viral and host factors that individually or interactively contributes to endothelial dysfunction and vascular permeability in dengue infection. We will address that research question through two parts in our study. First part is assessing previously mentioned viral and host factors in dengue patient. Second part is determining the effect of selected viral and host factors on endothelial dysfunction and vascular permeability through in vitro. As we are currently working on the first part of the study, today I'll be presenting the brief of results and conclusion on first part of the study. So, the patients who tested positive for generic qPCR and NS1 rapid test were included in our study, and serotype specific qPCR was done for generic qPCR positive patients. According to the results, dengue virus 2 and dengue virus 3 can be seen as the predominant serotypes in our group. This finding aligns with the previous finding of Malavige et al. In Sri Lanka. And qualitative and quantitative ELISA were done for half of the batch of our sample at the moment. So according to the results, NS1 is significantly higher in DF patients and IgG is significantly higher in DHF patients. You can see in the table. And both findings line up with the previous literature. And according to the qualitative IgM results, no significant association can be detected between DF and DHF patients. This finding also aligns with the usual pattern of dengue infection. Finally, we have analyzed the correlation between day of fever and IgG levels of patients. And there is no statistical significance between these two parameters, but a negligible correlation can be seen here, and we can assume that these IgG levels are not only from this infection but also from previous infection. So at the moment, we have that results only. We are working on the first objective. Still, we are working on the first objective. So we can't conclude the all cohort at the moment. This is the study workforce for now. Thank you so much for listening.
Next, we have Abira Satikunanathan on genomic surveillance of Mycobacterium tuberculosis and non-tuberculosis mycobacteria.
Good afternoon, everyone. I'm Abira. Today, I will be sharing our ongoing preliminary research on a comprehensive genomic prevalence, surveillance of extrapulmonary tuberculosis and non-tuberculous mycobacteria in Sri Lanka, unraveling pathogen genetic markers for precision diagnosis. I am conducting my study with the guidance of my supervisors. So, tuberculosis is a millennial-old infectious disease caused by a bacterium called Mycobacterium tuberculosis. This bacteria most frequently affects the lungs. The common symptoms of the disease are persistent cough, fever, chest pain, and weight loss. Dr. Robert Koch has discovered the tuberculosis disease on 24th March 1882. Since then, it remains as the deadliest infectious killers in worldwide. Initially the bacteria affects the lungs and it can be transmitted to the other organs of the body. So it is called extrapulmonary tuberculosis. Non-tuberculous mycobacteria refers to a diverse group of mycobacterial species other than the Mycobacterium tuberculosis complex and Mycobacterium leprae. According to Global Tuberculosis Report 2024, 10.6 million active cases, 1.25 million deaths occurred in the world due to TB in 2022. In Sri Lanka, around 8,000 total number of TB cases reported in 2022. Among them, around 2,000 cases were extrapulmonary tuberculosis. So there is a significant need of strengthening molecular genomic surveillance for extrapulmonary TB in Sri Lanka. So the main objective of my study is to conduct a comprehensive genomic surveillance of extrapulmonary and non-tuberculous mycobacteria by integrating pathogen genetic marker analysis. Specific objectives of the study are screening for rifampicin-resistant and multidrug-resistant tuberculosis in extrapulmonary cases, determining genomic cues of extrapulmonary TB, developing a point-of-care diagnostic tool for extrapulmonary TB, and optimizing a pan-PCR assay for differentiating non-tuberculous mycobacteria species in clinical samples. The methodology of the study falls into main 5 methods. Initially, clinical samples are being collected from Center for Tuberculosis and Diagnosis, Faculty of Medicine, University of Colombo. 196 extrapulmonary TB samples, 100 non-tuberculous mycobacterial suspected clinical samples are my target samples size for my study. Sample collection will be followed by culture-based identification and molecular-based identification. In molecular-based identification, DNA extraction will be followed by primer design and optimization and real-time PCR and whole genome sequence analysis. So in culture-based identification, clinical samples from extrapulmonary TB cases are being successfully processed and cultured using LJ slants and Middlebrook 7H9 broths, incubated at 37 degrees Celsius for 6 to 8 weeks. So here you can see the presence of creamy white wrinkled colonies of Mycobacterium tuberculosis in LJ media after 21 days of incubation. And here you can see the small thin rod-shaped Mycobacterium bacilli, tuberculosis bacilli in 1000 magnification. In molecular identification, in future, DNA will be extracted from LJ or Middlebrook 7H9 grown cultures, and a sequence-specific real-time PCR for Mycobacterium tuberculosis complex will be designed, and a sequence-specific real-time PCR for non-tuberculous Mycobacteria species also will be designed. As Robert Koch has stated in Nobel Lecture 1905, the struggle against tuberculosis is not dictated from above and has not always developed in harmony with the rules of science, but it has originated in the people itself. If the work goes on in this way, in this powerful way, then the victory must be won. So this quote reminds us that TB control must combine scientific progress and with public health commitment. So here we are in 2025, still struggling. So let's hope for a zero TB world in future. So thank you all who are immensely supporting for my study. Thank you.
And with that, ladies and gentlemen, we have come to the end of our session today, themed Diagnostics and Public Health. I thank all our speakers, the chairs, and all the flash talk speakers for delivering such an informative and a very insightful session today. I was reminded of something while I was standing behind the curtains. I was reminded of something Professor Inoka always used to tell us during lectures. He used to tell us, you all should talk science over your cup of tea. And we really couldn't understand what he was trying to say. But today, standing in front of all these beautiful, like all these researchers, these great minds, it makes perfect sense, because as brought out by most of our speakers, science thrives and relies on communication and collaboration. So with that being said, now we will be taking a break for lunch. I invite all our guest speakers, all the participants and everybody here to collaborate, to communicate over your lunch, to talk science, to get the flow going. And if there are any questions regarding the talks that were delivered up on stage, please feel free to contact and communicate the speakers, and hoping to see you at 2 p.m. here to continue with the rest of the proceedings. Now I would like to invite you all to the 4th floor of the IELC building for your lunch breaks. Thank you.
As a theme for the session, communicable disease surveillance and prevention. And I added the word Sri Lanka. So we are talking about communicable disease surveillance and prevention in Sri Lanka. And this topic is dear to me because I've been doing exactly that for the last 20 odd years, starting from the regional level and then coming to the national level. So respected chairpersons, international faculty from RKI, academics from science faculty and other organizations, ladies and gentlemen. I wish to take this moment to talk a little bit more about the One Health Forum and thank the forum for inviting me for this talk. In my brief talk on communicable disease surveillance and prevention in Sri Lanka, I will touch on 3 eras. First, I will give a glimpse into the past, highlighting the legal framework, public health structures, and key achievements. Next, I will focus on the present, emphasizing on the expanded program on immunization, or better known as EPI, our public health game changer, and how it has accelerated the elimination of several vaccine preventable diseases, especially the childhood diseases, saving thousands, if not millions, of lives throughout the life course. And finally, I will share insights into the future with emerging primary preventive techniques under the One Health framework. Before I begin, I would like to clarify a couple of technical terms. Communicable disease surveillance refers to keeping a continuous, organized watch on infectious diseases to detect cases early, monitor trends, and guide timely prevention. So basically, in simple terms, collection of data for action. That's what we do basically by doing surveillance. Disease prevention, on the other hand, involves taking measures to stop diseases from occurring, spreading, or causing harm to individuals or communities. Sri Lanka's strategic location along maritime trade routes in the Indian Ocean, with links to busy ocean lanes and proximity to Indian subcontinent, has historically influenced infectious disease dynamics. The Quarantine and Prevention of Disease Ordinance was introduced in Ceylon, Sri Lanka was called then Ceylon, in 1897, over 125 years ago, concurrently with the British India, to prevent the transmission of plague outbreaks, also known as the Black Death, affecting parts of the western Indian coast. The bubonic plague, characterized by swollen lymph nodes or bubones, is caused by bacterium Yersinia pestis and is primarily a zoonotic disease transmitted from animals, mainly rodents, to humans, often through fleas, such as the rat flea. Over time, the list of quarantinable diseases expanded to include smallpox and any other disease specified by notification in Gazette. This law remains valid to date and was applied effectively during the COVID-19 pandemic. Importantly, individuals cannot legally challenge quarantine measures under their fundamental rights. So it's a very strong law. The first health unit in Kalutara, Sri Lanka was founded in 1926, marking 2026 as the centenary of a structured public health workforce, which included epidemiological activities such as the surveillance and prevention of infectious diseases and epidemics. Under the Quarantine Ordinance, a list of notifiable diseases was first published in Ceylon Gazette in August 1927. The list has periodically updated to include new diseases, especially to monitor vaccine preventable diseases. The National Epidemiology Unit was established in 1959 with the assistance of the WHO, the World Health Organization, to strengthen the surveillance of communicable diseases. Surveillance and vaccination of at-risk populations were the two main strategies for disease prevention. Over time, the unit's role expanded to become the focal point for national immunization program, developing policies, regulations, and guidelines, managing vaccine logistics, ensuring immunization safety through vaccine preventable disease surveillance, conducting regular training and monitoring and evaluation, and generating new evidence through operational research. With the implementation of the Expanded Program on Immunization, or EPI, in 1978, the program improved in a structured and standardized manner. Today, the National Immunization Program protects against 12 major preventable diseases. It is planned and implemented at the national, district, and divisional levels. supported by laboratory surveillance from the Medical Research Institute of Colombo, part of the Ministry of Health. The last virologically confirmed case of wild polio virus in Sri Lanka was reported in November 1993. 21 years later, in 2014, the World Health Organization declared Sri Lanka polio-free, along with the entire Southeast Asia region. The success story of 50 years of EPI will be officially celebrated in 2028. With effective control of transmission, Sri Lanka has certified as having eliminated measles, with no indigenous virus transmission for a period of more than 3 years by 2019. A well-performing surveillance system with a discard rate of more than 2 fever and rash cases per 100,000 population was a key performance indicator in this endeavor. However, in 2023, Sri Lanka faced a significant measles outbreak amidst escalating global outbreaks linked to low vaccine coverage during the COVID-19 pandemic. Globally, the uptake of measles containing vaccine 1 and measles containing vaccine 2 had fallen. And once movement restrictions were lifted, transmission increased. In Sri Lanka, despite maintaining more than 95% measles immunization coverage even during the pandemic, there were 810 cases of measles, primarily affecting infants under 9 months and adults aged 20 to 30 years of age. The root cause analysis identified that isolated pockets of people perceiving misconceptions about vaccine safety and efficacy, contributing to vaccine hesitancy and refusal, were the main causes. To strengthen surveillance and vaccine uptake, several measures were introduced, including involving the general practitioners in the surveillance process and establishing a proactive advocacy network to ensure early detection of suspected cases to encourage vaccine acceptance. In August 2024, Sri Lanka conducted a zoonotic disease prioritization exercise using multi-sectoral One Health approach involving human, animal, which is livestock and wildlife, and environmental sectors. A ranked list of 10 prioritized zoonotic diseases were identified, with leptospirosis, rabies, and zoonotic influenza coming as the top 3 diseases. Leptospirosis, rabies, and zoonotic influenza were the 3 top diseases. Leptospirosis is a major zoonotic disease in Sri Lanka, with peaks after monsoon rains and during paddy cultivation. In 2024, over 13,000 cases were reported with a case fatality rate over 2%, which is relatively high. A multidisciplinary technical committee on leptospirosis is now supporting 4 thematic areas: laboratory diagnosis and clinical management, surveillance, multisectoral collaboration, and operational research. An external independent review of the National Rabies Control Program was conducted in September 2025. Although Sri Lanka is well poised to accelerate human rabies elimination by targeted 2030, critical gaps remain in intersectoral collaboration, dog surveillance, mass dog vaccination coverage, and data integration. Establishing an integrated and strategically aligned surveillance and prevention framework is essential to ensure all sectors work together, leveraging collective strengths and resources to address challenges posed by climate change, industrialization, urbanization, and other emerging threats, without duplicating existing functions. This approach enables a resilient and responsive public health system to safeguard the health of all Sri Lankans in the long run. For effective One Health implementation, the way forward includes establishing a multi-hazard, multi-stakeholder routine surveillance system integrating human, animal, and environmental sectors. A structured, multi-partner, all-hazard event-based surveillance system will enable early detection and timely information sharing, This involves joint rapid risk assessment, simulation exercises to evaluate national and subnational capacities, and strengthening workforce capacity through expansion of the current field epidemiology training or FATP to include human and animal health sectors. Sri Lanka is also conducting wastewater surveillance in phases to strengthen environmental surveillance for infectious diseases. The first phase will focus on polio eradication, verifying the absence of polioviruses and maintaining the country's polio-free status. The second phase will expand to other enteroviruses, improving understanding of viral transmission patterns and enabling early outbreak detection. The third phase will include other critical public health threats. A phased approach ensures gradual strengthening of laboratory and field capacities, method refinement, and efficient use of resources. The Pandemic Fund has provided a substantial grant to enhance Sri Lanka's pandemic prevention, preparedness and response (PPR) capacity. This support allows the epidemiology unit to expand surveillance, intelligence, and early warning capacities, moving towards a center of excellence for disease prevention and control. Transitioning to a CDC-style system provides opportunities to streamline surveillance, enhance coordination, and integrate data across national systems. Under the CDC structure, digitalized data flows will link field and laboratory data, enabling seamless integration of preventive, diagnostic, and response functions with a unified framework. This system architecture will support the timely use of multi-source information for risk assessment and decision-making, making disease control operations more agile, data-driven, and responsive to emerging threats. A strengthened One Health collaboration will link human, animal, and environmental health data, facilitating early warning and risk assessment of zoonotic and climate-sensitive diseases, including arboviruses, which I am fond of. In conclusion, ladies and gentlemen, Sri Lanka's journey in communicable disease surveillance and prevention reflects over a century of evolution, from early quarantine laws and health units to current immunization programs and integrated One Health strategies. With continued innovation and multi-sectoral collaboration, we have positioned ourselves to protect the health of all Sri Lankans and the visitors against current and emerging infectious threats. Thank you very much.
And so the second speaker for today's this session 3 will be Dr. Taraka Prasad. He's the Director of Wildlife Health and at the Department of Wildlife Conservation. And Dr. Prasad will be speaking on One Health approach in wildlife management. Over to you, Dr. Prasad.
Thank you for given opportunity for speech this on topics, academias, professionals, scientists, and ladies and gentlemen. Thank for the organizers to invite me for this speech. I'm Taraka from Wildlife Department. You know, One Health is 3 pillars. It's an environment, animal health, and human health. Is integrated approach to recognize the interconnection between people, animal, and the environment health. The core concept of One Health is One Health brings together human medicines, veterinary medicines, and environmental health. It promotes data sharing, surveillance, and policy coordination across the sectors to manage shares health risk. Why One Health is important? It's we know at 60% of emerging infectious disease are zoonotic. Out of these, more than 70% disease have wildlife in origin. So it's a mainly focus for the wildlife sector and the environment. And environmental degradations also increase the disease transmission risk. Globalization, deforestation, and climate change are intensify the spread of disease across animal species. Integrated management ensures sustainable health outcomes. So, under the World Organization of Animal Health, it says 60% of the pathogens cause human disease originate from the animal health, and out of 75 of them are in animal in origin, and 80% of pathogens that are bioterrorism concerned originate in animals. So it's high level shared for the animal origin. So another World Animal Health Information System, WAHIS, it gives a decision where the disease is moved around the world. WAHIS has a good network collected among the parties. So every country should put their input for the WAHIS at the annual reports as well as the tri-annual reports, quarterly reports. So this gives us prediction. I mean, when we facing the threat, we will got the information before facing the threat. It's also available in WAHIS apps available in the both Apple and the Android. So it's get quick informations where the disease is transmitted. WAHIS alert applications allow the use of receive constant directly on the mobile phones and tablets as well. The disease alert immediately notifications on monitoring reports related to the World Organization for Animal Health. These are the links. WOHA information system is WAHIS portal provide easy access of these tools for more accurate results with searching the world animal health information. Guaranteeing transparency of the world animal health situation is one of the primary mission of WOHA. WOHA members has obligations to submit the information of their animal health situations and list of the terrestrial and aquatic animal diseases notifiable to WOHA has been established for that purpose. WAHIS is an early warning system which immediate management alert notification for WOHA listed disease and emerging diseases. It's a monitoring system to make 6 monthly information update to all WOHA listed diseases, and it's further information provide national authorities through annual reports on animal diseases affecting human populations, animal populations, veterinary service capacities, and professional laboratory capacity and vaccine productions. These key sectors involved in the One Health is human sector, animal sector, environment sector, and policy and governance sector. Wildlife plays a critical role in maintaining ecological balance and disease dynamics. Department of Wildlife Conservation is involvement of One Health initiatives help to monitor and control zoonotic disease outbreaks in wild. So far we have several outbreaks, not only the zoonotic but also several disease outbreaks has been reported continuously about 4 or 5 disease outbreaks in my 29 years experience. It's promote habitat protection, reduce cross-species disease risk, and also support national and global health security through conservation. And DWC, Department of Wildlife Conservation role in the National One Health Framework is active engagement of National One Health Coordinator Committee and conduct wildlife disease surveillance and research. Yes, we do HPI surveillance with a collaborative with the Department of Animal Production and Health, especially under the migratory seasons before migratory season began. In conduct wildlife supporting to policy development training programs and collaborating with health, agriculture and environmental sectors. Feature directions strengthen the national One Health coordination, extended wildlife disease surveillance and disease research and diagnostics, enhanced community-based surveillance and integrated climate and biodiversity indicators into the One Health planning. When we talk importance of One Health in wildlife, preventing and controlling zoonotic diseases, protecting biodiversity and ecological integrity, safeguarding human and livestock health, supporting sustainable development and coexistence. Challenges and gaps. We have limited cross-sectoral coordination mechanisms in Sri Lanka, insufficient funding and lack of human resources, especially in wildlife department, lack of data sharing and integrated surveillance, need for stronger public and policy engagement. Summary, One Health provide a combined framework to protect human, animal, environmental health. Department of Wildlife Conservation involvement ensure that biodiversity and wildlife conservation remain the hearts of stable, sustainable health systems. In surveillance of monitoring wildlife diseases, we have, as I said, we have few outbreaks which are not zoonotic. In FMD in 2002, Habarne, there are two or three elephants have been affected. Newcastle disease in 2020, Kotuattala tank, and rabies in 2020, Millennia jackals, and 2024, Homagama deers, 23 Homagama deers, and African swine fever and porcine reproductive syndrome in 2024. And we have also a suspected hemorrhagic septicemic disease, it's HS, caused by the hemorrhagic septicemic bacteria, caused by the bacteria. Disease samples took in Ruhunu National Park, Vendome and Demalia part, and also suspected FMD outbreak in southern boundary of the Somawati National Parks, and suspected tuberculosis infection at Horopatana Urulura Sanctuary in elephants, and Pasteurella pneumoniae infections confirmed at Bundala in drought in monkeys. In significant mass mortality occurs where wildlife are congregate as a seasonal breeding and feeding grounds. More difficulty monitor these diseases in wild than domestic animals because they have high scavenger actions and you can't see carcass for a long time. It's disappear in a few hours after scavenging actions. This is a FMD outbreak of elephant. This is a FMD outbreak of baby elephant, its foot sole has peel off. And this is a Newcastle disease outbreak in Kotuattawala, Nikaratia. And also the wildlife, wild animals can be act as a reservoir of disease. Most of them have no ecological boundaries as freely moving as migrants. Mass mortality events involving wildlife may be often occur at unpredictable. And also there are some finding occur in very recently among the macaques. Treponema pallidum, organism found in some macaques in Polonnaru area. Still investigations is going on. And this is the Homagama deer rabies incident which come from the dog. And you know that deer is an end host, so there is no infections go through the deer to the other species. And this is a kind of bird, it's a pelagic bird, it's sooty tern. This big bird carry a Newcastle disease, Panicut outbreak. So he got 2 rings in his legs, which identified, and it's confirmed by the ornithologist, British Trust of Ornithologists, that bird it was ring in 2008 in West Madagascar. So this is bird flyways. We have 9 flyways and belongs to Sri Lankan, is a Central Asian flyway. Last destination is Sri Lanka. So this bird has a ring in different flyway. So when there's a chance to mix these birds among the flyways, and he ultimately come to the Sri Lankan island, which are not come normally because of the weather and the disease pattern. Any disease has infected, the birds come. So lastly we found that animal had a Franicot and the animal has died. Disease of wildlife can occur in different forms of the wild range of animal species. Symptomless outbreaks and also sudden deaths. Subclinical outbreaks also happen. Episodic outbreaks, different outbreaks. Disease when expecting free-ranging animals have been significant effects on wildlife ecology. These are the migrant birds. It's also migrant birds. These are pallidum infected monkey. This is a millennia rabid jackals. We have found in 17 jackals are infected with rabies, Hola positive. Infections cross-check. These all come from the dogs, not any silvotic strains found. And very recently, there's a African swine fever outbreak happened. It's a death of farm pigs. And this is a kind of turtle death due to the ship disaster. And this is also part of this. Thank you.
Thank you, Dr. Tharaka, for very important presentation. And we will move on to the last presentation in this session. The presentation will be delivered by Dr. Lukas Murajda. He is the head of Health Authority for the district of Central Berlin, Germany. And his presentation is titled as Challenges of the Surveillance of Vector-Borne Diseases in Berlin, Germany. I warmly welcome Dr. Lukas Murajda.
Thank you. I like to move, so I prefer the one that moves with me. Thank you. I showed the traps to someone during the pre-last break, and they told me that I should take it with me, so I have my guns with me. You will know why I say guns later. So, dear chairs, dear officials, dear professors, dear colleagues, dear future colleagues, dear friends, it's an honor for me and a joy to be here, learning from your vast experience and sharing my thoughts with you. First, maybe let's put it in a frame so that you have a feeling, because I'm an exotic species here. There are not many bureaucrats, or I would say at least more mildly managers here. I think it sounds nicer than a bureaucrat. So I was a researcher in my previous life, some 15 years ago, but since then I've changed to the dark side. And now I'm the one giving money or hiring people all the bad things, or closing some things, because I'm active, as we heard, in the public health. I like to describe myself more as a medical sheriff, because I'm trying to protect the people in the city of Berlin. Explicitly, the whole city when it comes to the vectors. And now comes the topic, the theme of the talk, because about 3 years ago I was appointed to organize the surveillance of the Asian tiger mosquito in Berlin. So that's the frame where I would be moving my thoughts and myself in this talk. It's about surveillance, and it's actually about the Aedes albopictus. I do a lot of other things, so this is more like fun, and I really enjoy doing it. I will not be talking about numbers, because the numbers, Berlin compared to Sri Lanka, are absolutely not important. So I decided to talk about my thoughts. How should surveillance be organized? You all know what is surveillance. You all know how it should look like. But still, I would like to give you my perspective. What are the things that I find relevant, or where I see the most, let's say, mistakes when we are trying to build a system, especially based on my own experience and my own mistakes. And now we come also to the guns, because you know that I'm a sheriff now, and that I will be talking about Aedes albopictus. So I brought some symbolic gifts for the Department of Zoology, so that they can kill even more mosquitoes. Sorry for all the biologists who love the mosquitoes. I just study them to kill them, I have to admit. So there's one thing called GAT. You will see it also in the presentation. That's for the gravid mosquitoes. And this is the normal BG Pro. I can unpack it then if someone really wants to see it. Otherwise, the colleagues of Professor Inoka will use them later. So, surveillance from the French, surveillance. So we are trying, the term was first coined in France, because they were trying to observe the criminals and to know where they are, how they move, and what will be the next move. So that's how we started with surveillance, and we do the same with the diseases. We are trying to track them to protect the public. It might be a very simple picture. I just used the tools in the PowerPoint, how do we call it, software, PowerPoint software. So don't focus on the quality of the picture, but I wanted to stress the meaning, because you know what surveillance, you know the steps, but I really wanted to focus ourselves on the circle, because mostly, and here I'm coming to the first bullet point, the complete loop. Most of the time, even in my case, when we are trying to organize a new surveillance program, we start nice, we do things, but we don't complete the loop. At least, even though many times, especially in Germany, they are very good. I'm not German, you see, but I love to learn from them, and somehow they tolerate me. So I see that they go further than we do in Slovakia, where I come from, because most of the time in Slovakia, there is a program, the ministry gives you some money, and you do something for 2-3 years, and maybe you even publish, and that's it. You don't close the loop. You don't check if it was good. Should we do it? Should the next loop be different or not? Should we even have a next loop? Or should we create a new loop? Because these loops should be loops. It shouldn't be one circle. It should be a complete circle, but it should be also a sustainable circle. Circles. We should be looping forever. That's what we should do in public health. Not a program. Sorry for the researchers, you only want to publish. But public health is about sustainability. You have to run it forever. There's one joke about the German administration that if you establish something, it's just forever, you know? That's how the bureaucrats work. That's why the laws are so important, because if you establish something, it should actually last forever. So it should be sustainable, it should be complete, and if it's not quick, forget it. If you send your samples to Robert Koch Institute, or even if you test Mpox and you have results in 2 weeks or later, what for? You can publish nice things, but for public health people, it does not have a relevance. If you don't have the result on the same day, then it's not useful. That's what I mean with quick reaction. If you want to have a good surveillance system, you should be able to react quickly enough to do something, because I think already 3 people said it before me, data for action. I've been a researcher, so let's say we focus more on data, but actually we should more focus on action. And action can come only when you're quick enough. Otherwise, the Mpox, you meet them, maybe they are symptomatic, but then you will lose them. And if you have some hard to reach populations who come to some health center somewhere, then they disappear. As soon as they get acute help, they get lost to follow up. So quick reaction. Competence. I think it was also in the talk yesterday. I don't mean us. We should, of course, be competent, but I mean all the decision makers, all the people involved should be competent. We cannot be competent in every field. I don't know much about environment. Now I know something about mosquitoes, but actually not that much. I might know something about medicine, but I haven't been practicing it since I started my scientific career. But I am kind of competent in some fields. But you should cooperate with other competent people. You should involve all the stakeholders. And actually, I will come to this competence idea on the next slide. I don't mean that everybody who works with you needs to be competent. Actually, it probably doesn't tell you much, but there was a very important empress of the empire where Slovaks lived 100 and more years ago. And she said, so the name is not important, but she was like very Maria Theresia, okay, whatever, a very, very famous empress. For people from Berlin, it's problematic because we are fighting against the Prussians all the time. So, okay, but for people who come from where I live, this was a very important person. And she said, the army is so good as the officers are. Because we have, every country, even a poor one or whatever, you have professors and they know a lot. These are like generals. It's very good, it's very important, but you can fight with generals. You need the army. And actually the soldiers, the students, the people you hire and exploit because you have them and they just want to do some project, they don't need to know that much. They need to be there. You need people. But the quality are the officers, are the people who support you, the technicians, the second in line, the vice chancellors and vice department heads. These are making the quality because they lead your, I shouldn't be that military, they don't like it in Germany, but okay. So you need the soldiers, but you need the officers because they see the people who really work. They follow them and they check the quality. So that's what I mean by the competence. Stakeholder, I think this is the second most important mistake that I've seen after the complete loop. We don't involve everybody. That can mean something like you don't involve public, so the people don't know, don't understand. Or you don't involve partners that are important. Imagine that your department does something and the colleagues are actually relevant, but you don't tell them to have the grant only for yourself, and then they will block your project. So I mean also things like that. Or you don't persuade your politicians, and they don't understand, and they will not finance your project after the first period. So you have to win all the stakeholders. It's very, very important, and I think most of the projects or programs of surveillance for something were not successful because of this, because they were not able to make a team out of all the people who should be relevant. Okay, sustainability, I already talked about that, and I mean it, cheap, not cost effective. Cost effective, yes, of course. We should be doing everything according to the best knowledge and what's the word for that? Moral principles, yeah, because we have public money in our hands. So we should be spending them wisely. But I don't mean cost effective, I mean really cheap, because nobody, even Germany, even Singapore, nobody has infinite amount of money. You always have to prioritize. So if you can make things cheaper, that means you can do other things. And you will never have so much money that you don't need to think about it. So whatever, try to make it as cheap as possible. Okay, how to reach this perfection? It's almost impossible. I think it might be not complete, but when I think about perfection, and explicitly when I think about the lecture of Professor Nilika from yesterday, I was thinking what I would suggest Sri Lanka and us to improve things. And based on the things I know in Slovakia, in Austria, in Italy, and in Germany, I think most of all we lack leadership. That's why I'm so happy that you organized this here, because this is kind of leadership. If Professor Inoka and Professor Andreas wouldn't make this collaboration, then there would be no leadership, there would be no One Health Forum, and the things would not move on. This kind of leadership. You need people like prophets who just believe in the thing and they work and they shift the things so that they make the things done. You need these people who motivate the others, they show them the way. But again, these are like the generals. Maybe generals, prophets, great, but still not enough. You need the teamwork. That's what I already said. You also see it on the picture. You need the people, and again, it was already in the lecture of Professor Nilika, and I think that's the game changer. You need the team, not the team of a professor, but the team of the stakeholders that go and follow this idea as a team with different competencies. But still they need this, I couldn't find a better term for that, but okay, let's call it framework of authority. It can be an authority given you by the state, it can be a law, it can be your competence because you're the leading general in your field, but you need to have some kind of authority because not only that people trust you more if you have the authority, but you need the framework to make the things work. Okay, we can discuss it later more, but I think it was described enough. But still one more message. I believe that the ratio of all these three is like joint vessels. You can have less leadership, but if you have good laws, good labs, everybody knows what he's doing, so the framework, and if you have the team, it might work. It's still better if you have leaders and leadership, but the ratio can be different. If you have other two things strong enough, then it can compensate. But if you want to be really perfect, if you want to reach the perfectness, how did I call the thing? Perfection. Then you need ideally all three, but you can compensate with other two. So that's why the joint vessels, I think. Okay, yesterday I went to a shop, Cargill's, something like that, and they wore T-shirts, and there was, "We are serving the nation," or "We want to serve the nation," or something like that. I really liked it. I thought, like, wow, in the shop, you know, like when I go in Berlin to a shop, I think, oh, the prices are too high, they are just making business and want to sell all this. I never think about the people who are working in some shop as serving the nation. So if you live this in Sri Lanka, you're already on the way to be better than Singapore. Because if people believe that they are serving the nation, be positive. At least that was great. Someone who designed these T-shirts, I love it. So how can we serve the nations? We, of course, need to be almost godlike and have many hands, but I was thinking about these three things. And I really mean it in this Reihenfolge, in this order. Because normally, you people think, first of all, about research, which is very important because this moves the things further. You see the future, you can answer the questions. It's very, very important, especially if you are a university. But of course, you need to do also science. Yeah, you need the knowledge. You need to know how the things work. And if you organize a surveillance system, you should be thinking about these things because you work with data. That's why I think we lose so many opportunities in public health. As I said, I work for the public health agency. I'm the medical sheriff. Yeah? So we have a lot of data. I believe it's the same with the colleagues here in Sri Lanka. You have some departments of public health, those district services or however you call it. And I would bet that they do the same mistake as we do. They don't work enough with their data. And they know so much. It's the first hand. It's not only an opportunity, you must publish because it's the evidence that flows through your hands and you have to share it with the researchers and scientists. So if you create a surveillance program, think about research, think about science, but, and now for you, don't think only about research and science, think about outcomes. People need to eat. That's why the rice bowl. They have to see the outcome. If you do something scientific and it doesn't mean anything for the public, for the politicians, they will not support you. Give them something where they see why your science and research makes a difference for their life in this year, or at least in this, how do you call it, legal period? The politicians live through, okay, the period when they are elected. Actually, they are interested only about those 4 or 5 years. So give them something so that they see results. So outcomes, science and research. So what do we need for that to be perfect and to organize it well? Again, not a complete list, but my thoughts. Sustainable budget. If you get money for 1, 2, 3 years, it's nice, but it's not surveillance, it's a project. Make it cheap, make it sustainable, motivate people, do less, but do it sustainably. It will be better for science, better for research, and better for the public. You need tools, of course. You need the PCR, you need the things that you work with. Ask for them, buy them. You need people. Again, not everybody has to be a professor. You need a lot of good middle officers. But then you need also people. You need just hands. Especially when, and now back because you probably already forgot that I was actually talking about surveillance of the tiger mosquito in Berlin. I need hands. I don't need people who understand what we do. I just need a lot of students who just go there, put the trap and bring the mosquitoes back. And they actually don't even need to know what they are doing. They just need to do it. It's of course good and it motivates them, but you just need hands. And shared vision. At least, and this is what they need to have. They don't need to understand everything, but they need to know that they are doing something that makes sense. Because otherwise they make mistakes, the quality goes down. So shared vision. Okay, who and when? Thank you. Again, we have heard it today before it gets necessary, not when the mosquitoes are everywhere or when the rabies is in all the wildlife animals. Before, because then you can see the difference. Please stop me when I'm already bad with time. Will there someone be? I still can talk? Very good, thank you. So, of course, before, because then you have the baseline, scientifically, no need to tell more. One Health. Again, I come from public health, from the medical perspective, but without people who understand the zoology, without the people who understand the environment, you cannot move further because you don't know how the things work and why there are some influences which you have not expected. But I think that especially when it comes to the tiger mosquito, we are the ones, the public health, because we have the human data. We should do it together, but if we want to be quick and if we want to make a difference, I believe it has to be seated within human health, because there is almost no problem in data protection, in strategic meaning when it comes to animals, but it's a very important thing when it comes to humans. So if we are organizing the things, we already have the data. So if the zoological and environmental colleagues help us, then we can do it right. Okay, just 2 more slides and then we are ready. This is actually the content of the talk. So first, what do we do good in Berlin? I think we can react. Again, now I'm only talking about the surveillance of the tiger mosquito. I think we can react very quickly. We are able to send teams, set the traps, check what's in them within, let's say, 48 hours. Even almost included the lab, because the colleagues at the Robert Koch Institute are so motivated that if we bring something even in the evening, they stay at work and do it. So 48 hours, quick reaction. We have some competence. We have an official working group at the, you would say probably something like a region, but we call it state level, because Berlin is very big and we are like Washington, D.C., so we love to call it a federal state. And we have a working group at this federal state level. I think our solutions are quite cost effective. There's leadership because the something like the regional Ministry of Health recognized its role, and they are organizing this surveillance and giving us the legal framework. We have a plan agreed with all the stakeholders within the state, and we have high-tech tools, which I love to play with. But there are things that we don't do well. We don't have this complete loop because we just do monitoring now, and we are struggling to find a consensus what the measures should be. How should we fight the mosquitoes? The topic is adulticides versus larvicides or nothing. It's a very broad discussion and we don't have a consensus. The competence is there, but we don't have enough people, not enough generals, not enough officers, so little of the staff. Also, awareness among all the professionals is low. So when I talk to the medical doctors in Berlin, they kind of don't really care yet. So there's still a lot to do. I have to say, even the environmental people are not really involved. But, I mean, they're still like, they see other problems as more important, I would say. Public as a resource, yes, only partially. We have some campaigns, but there's still a lot to do. Not that people don't care. Actually, the public is quite scared and they ask for solutions. That's why we were able to get some finances and some support from the politicians, because they care about the public. But the problem is the public doesn't, from my perspective, really see the problem. They are just scared that there is this tiger mosquito, but they don't get the whole picture in definitely not in One Health perspective. We don't have a sustainable budget. We don't have the law that would really set the rules. As I said, there's little contact with environmental partners, but I believe that's the next step that we will achieve. And well, we still have no full-time medical entomologist, which we compensate in our joint vessels with technology, but it's not ideal. And the vision is not really shared. That's why we do only the monitoring and we struggle about the measures. Saying this, I would like to thank you all for your patience, that you listened to me, for the invitation and the opportunity to tell you about my opinion about surveillance. And I hope that we will discuss it more during the after session talk. Thank you.
I would like to invite the chairs of the session as well as the speakers to come up on stage to proceed with the discussion.
First, I would like to thank all our speakers, Dr. Hasita, Dr. Lucas, and Dr. Prasad. So now the floor is open for questions and to discuss the topics that was explained by the three speakers. I would like to open the discussion by asking now, we are all talking about data for action, and in the sense of like digitalization and everything, Sri Lanka and in Berlin, in what is being done in terms of like using techniques like GIS and also things like that for surveillance. For actual time and space equivalent monitoring.
Should I start? Yeah. Thank you. For that question. I did. Yeah. Can you hear me? Yes. So thank you for that question. And in surveillance, most countries have adopted paper-based systems originally. And some countries are, like India, for example, is generating more digital platforms from the inception. So Sri Lanka is having a dual system, I would say a hybrid system, where we have had paper-based systems for a very long time and gradually transforming into a digital platform, which is somewhat more complicated, I would say, because it's not straightforward, because people are complacent with having paper-based systems and they have, from time immemorial, they have been in place. So transforming that kind of a system to a digital platform has its own merits and demerits. So accommodating such systems will require not only capacity building, but infrastructure as well. So gradual transformation from a paper-based, log-based system to a digital platform takes some effort. So in that respect, the Ministry of Health has a blueprint, kind of an overarching structure where all the health governance is to be ultimately taken into one platform. But I'll speak to my area of expertise, where the epidemiological surveillance. Actually, to tell you a story, that our unit was the first unit to have a computer in the Ministry of Health. And people were coming to visit the unit to see the computer. I still remember, because I myself, when I was working in the region, we have not seen a laptop. This was not very far ago, a long time ago, but relatively in the recent past, 25 years ago. So we had that opportunity restricted in that respect, and then gradually now we are liberalizing. So that is now changing. the dimensions and the dynamics. And so the paper-based systems have always been used efficiently and effectively, although we know that there are delays. So there is a lag time between the time the information is generated to the time that you collate and analyze the data, and to make decision happen, there is a lag time. So minimizing that lag time is what we expect to do through digitalization in a big way, because it becomes real time and decision making can happen much faster in a more holistic way and in a much more stakeholder driven way. So coming back to what I said earlier, so using our platforms to transform it to more digital based platforms is happening. At the same time, we are trying to collaborate with other sectors, especially the Department of Animal Production and Health, which relates to our work very clearly, directly, and also with wildlife and the environmental sectors, because these sectors have lots of information that we would aspire to have hands-on, so that we can make decisions more holistically for the public betterment. So that's how we are trying to do it. So that process has started, and it's a gradual process. Things cannot happen overnight. It will have to take some time for us to completely digitalize. However, there are certain places where digitalization has happened relatively fast. India, for that much, that matter I know, they started digitalizing around 2015. Now there are systems, at least in the area that I work in, is almost 100% digitalized.
So I hope there is some pilot projects or things like that happening.
Yes, very much.
And Dr. Tissera, do these programs have an island-wide coverage?
Yeah, that's the benefit that we have, because we have a centralized system. So in Sri Lanka, whether it's the expanded program on immunization, or whether it's a surveillance of communicable diseases, the selective diseases that we currently do surveillance on, because on priority basis, because it's important for public health prevention, it's covered the nationwide. Okay. It has a nationwide approach. For example, when I listened to the Asia tiger mosquito story from Berlin, it occurred to me because I headed the dengue control program, and we started, transforming the vector surveillance when we had outbreaks way back in 2009. We had a similar situation in 2009, where the highest number of cases, around 35,000 dengue cases, with a substantial proportion of severe cases and about 350 deaths. The case fatality rate was 1% when we started working on dengue more aggressively. So now we come to a level where we have one entomologist per district, and there is an array of field staff, around 1,000 of them, doing just surveillance for the vector. So we've come a long way.
And I have another question to be asked from Dr. Tharaka. Dr. Tharaka, you mentioned about a threat, bioterrorism, some 80%. Can you elaborate on that?
Which also how this and we can
So, Dr. Lucas, can you share your thoughts?
Not only, do you hear me? Not only did I love to speak, so I had to take the word also for me, but I find it quite a funny and important example. Back to your question. We all have laptops in Berlin, but did you see I gave you at the end of my presentation not my work email address, but my private one, because we still have, all of us, the laptops, but we don't communicate with each other because we have all the fancy systems. But they are divided into federal and state and region and local, and they are divided between the environment and zoological and public health, and everything is separate. We're all fancy, but in our own bubble. So if I want to communicate with the colleagues from the Robert Koch Institute, I need my Gmail account because it works faster and better. So that's just as an example to your question how the digitization works.
So we can have questions from the audience.
Dr. Sarakav, the first one is for you because now I'm asking this from a point of the biological invasions from alien invasive species. You mentioned the African swine flu outbreak, right? It went all over Sri Lanka. Now, is that a new one or has it been there for a long, long time? I mean, we don't know when it first originated, when it first appeared in Sri Lanka, right? And then obviously my second question is, what can you say about quarantine measures for preventing the introductions of new diseases? I'm not talking about plants and other stuff because we know, right, the industries that are really guilty of, bringing in lots of new invasive species, alien ones. I think that it's because of the weak enforcement of quarantine laws that much of what we have to face with agriculture, livestock, and maybe wildlife, I don't know. What would you say?
In African scientific product as a bulk of
Imported milk.
Imported meat, yes. Sorry. Imported meats from the one agency. It's an illegal one. We heard it illegal one. So in policy, it's come to the illegally. That should be destroy or re-export. So there's no need to keep it there and to laboratory investigation of the illegal stocks. So that the authority believe that kind of misuse of the stocks and then its effect to the cloud areas farms, then it's spread. But we understand that it's a RRS, porcine reproductive respiratory disease syndrome. So we check it with one sample from the Pattuna park as well as the Dala parks, so it's come positive. In the meantime, we from these African swine fever, both are positive. So there's a concurrence infection both RRS and swine fever. But the department request to the public don't bring the pork products inside the parks, bungalows. While keep forming this, we thought it's protected some areas, but wild dogs over that. So it's and now it's all over.
Yes.
So now those days the infection going on in area, Nalatanya, quickly spreading disease, deadly. So ultimately that remain in the wild, come back again.
Yeah, it's all over the country because in Ratnapura, not Nalatanya, all over the, all the wild boars seem to be dying from this, right? Yeah, okay. So obviously it was not just lapse of quarantine, but we all know the reasons why illegal products enter and they are allowed to, So what do you think the Department of Wildlife Conservation could do for future ones? Maybe it's an unfair question, huh?
Yes,
It is. Okay,
yes.
all right. Okay.
We have found natural barriers anyway. So it can't be controlled by the vaccination.
Yes,
The disease can't be controlled by the vaccination. So there's no way to try to control that as a scientist. So we have to reduce the danger is he could wipe off the all existing species. There is wild boars because of the African swine fever is a deadly one.
Yeah.
Wipe off all the species, and book says that kind of animals can remain in the wild at the end of the process as a resistance one. Those can carry the virus.
Okay, right. Thank you. I shouldn't ask all the questions, but I have one for Lucas. I'll ask it later.
I want to ask this question from Tisera sir, as the epidemiology unit. I'm from parasitology, MRI. We were found so many nervous organisms as after 35 years we have found Valentidium coli, and that is also from zoonotic pigs. And nowadays, recent past, we were found monkey tapeworm. But we have to wait, and we are unable to make it to the public before we have to say epidemiology unit and allow us. They have to allow us, and so I have to wait 1 month. Still, we have not they have not given us the permission. So we MRI has published it. So could you please give us a real path, direct path from the epidemiology unit to us? It would be very easier to make it public to the media and also to make it awareness to the public society.
Thank you. Before that, let me go back to Professor Nimi's question. It became a human problem. Latter part of 2024, when the carcasses were getting left alone in the farms, and also some of the carcasses were, put into natural streams. They had nowhere to dump them, actually, perhaps. So they just ended up wrapped in polythene into streams. That was the worst part. So there were large number of carcasses being dumped in natural streams, and there was an element of human concern, of course, although the organism itself is not causing any human disease. People had a tendency to consume the product. So we had to restrict them from selling such carcasses, and there was then the public health teams have to come to the ground, So that's when the public health inspectors were called in, and they restricted all these farm animals to be sold. So that was a bit of a dilemma there, because that was challenging. Although it was not a human disease per se directly, there were, other human-related issues coming up, both in terms of environmental concerns, degradation, and also consumption of these carcasses that were stored in refrigerators, big refrigerators, and subsequently being sold, perhaps, which we thought was a concern. So that was another thing that we had to look into, and we had to issue a circular, give some circular instructions to prevent that from happening to the public health teams at the divisional and subnational levels.
Yeah, so there were no deaths or morbidity or whatever reported by eating those?
No, there was. I mean, Sri Lankans cook their meat well. We don't have barbecue kind of thing happening often.
Yeah.
So therefore, perhaps it didn't have a problem. I don't know what the
Does it
survival
kill
rate of these in the carcasses, Taraka, but nevertheless, there was nothing reported from human consumption of this. I really don't know whether anecdotally, I presume they didn't consume it in a big way.
Okay, so I mean,
Yeah.
thank you, Dr. Disa.
Coming back to your issue, we have the National Advisory Committee on Communicable Diseases, which is the governing body for all public health matters when it comes to policy decisions and recommendations to the Ministry of Health. So all policy decisions are taken at the advisory committee, where I think Rohita is a member of that committee. So when it comes to any public health related matter, whether it's limited to a geographic location or whether it's nationally or internationally concerned, it has to be referred to the Advisory Committee on Communicable Disease. That's the structure that we have. So going public, I presume that we have a system. Health Education Bureau has a regular mechanism to go to public. So they regularly organize these, public forums, especially with the media. Okay, so yeah, they are, yeah. So, sir, well, I really don't know whether it's a thing that has happened inadvertently, but I don't know whether there is any delay, because we have very regular contacts with Health Promotion Bureau, and whenever we need something to go public, for example, now during Maha season, when the cultivation start, people are asked to take chemoprophylaxis, doxycycline, especially the farmers. So that message goes through Health Promotion Bureau, and that reaches to the grassroots levels. So usually they are receptive of this information, and it carries forward. But yes, we do. We publicize it in the IDEAnet, weekly epidemiological reports. So we can put you in contact with Hamsa, has contacts with them. So we can certainly, because now when it came to chikungunya, last year, during the latter part of last year, 2024, we got the initial seeds of chikungunya being coming. It had not been there for about good 15 years. Last outbreak of chikungunya was in 2008 in Sri Lanka. And then we had this new spell, which came, we got to know through Medscape. Then 2 German, tourists to Sri Lanka ended up having chikungunya when they went back. That's the original information we got from Germany, where they tested those 2 individuals when they went back to Germany, and they tested positive for chikungunya. At the same time, there was a small cluster of chikungunya happening in an area where lots of migrants from Maldives live in Colombo, in the suburbs of Colombo. So that's how it originated. There was an outbreak of chikungunya in Maldives spilling over from French Reunion. There was a large outbreak of chikungunya in French Reunion, and then that was spilling over to Maldives, and then few Maldivians came here. We have abundance of mosquitoes. We have both Aedes aegypti and albopictus in abundance, particularly in urban settings. We have the primary vector for dengue, which is Aedes aegypti, year round. So both with the support of Aedes aegypti and albopictus, we had transmission of chikungunya, and that information was published in the weekly epidemiological report. So we can certainly get you to make such publications if it is deemed worthy, certainly through that mechanism. Sorry, I'm taking too long.
Okay, it's okay. Dr. Lucas, I have another question. Now, you have the monitoring program. Do you think that can there be any threat of vector-borne diseases coming from that mosquito?
Sure. Tiger mosquito is very competent. I don't need to tell you, you know better than me. That's why we do the monitoring, because we want to know if when it happens, we want to know quickly. So yes, sure.
Any further questions from the audience?
May I ask Dr. Lucas one question?
Yeah.
Your tiger mosquito, is it declared as an invasive species, not just a medically important species, but an invasive species? Yes.
Yes.
Now, who then does that list? Well, is it your organization or is it at the federal level?
So legally, we don't care that it's invasive, you know. Everything what can transmit diseases is of my concern and interest. So actually what I would need and what I miss, we have a special list of Schädlinge. So, okay, health relevant or medically relevant vectors. This is in Germany a state issue. So let's call it region, then it's more comprehensive. So for the region of Berlin, there is a legal list of every medically or health relevant vectors. And the tiger mosquito is not yet there. It's a more complicated issue. We can go on then on bilateral way after, but actually that's what I miss, because to be able to secure the measures, that would help me a lot, because I would have the legal framework. So we know it's invasive from the colleagues biologists. We know that it's relevant. Based on infection protection law, we still can do, but it's not explicit about the tiger mosquito. I hope that in the beginning of 2026, we'll get it into the regional law explicitly as medically relevant, which would allow us to do the measures more actively.
Thank you.
There is one more question.
Thank you. I want to answer the part of the question raised by the parasitologist MRI regarding the publications or publicity of any research finding to the public without making any panic. There's a routine way, as Dr. Tissera said, in the Health Promotion Bureau, every Wednesday around 10 o'clock, there's a media briefing routine program. If you want any public health issues, you can request through, if other ministries, you can request through our health ministry, and you can get the appointment in the Health Promotion Bureau. And I want to say an example. Recently, I think MRI had found that one worm, and they have published as a news message in the newspapers. And same thing, the University of Colombo Science Faculty, they have found first time Nipah virus in the bat. They didn't divulge in the public as a news item. They access Ministry of Health, and they properly do the publication in the papers, as they have found during the Kerala outbreak period. If that was in the public newspaper, every Sri Lankan will be panicked, and that won't be the case. But the science faculty did the good publicity for the Nipah virus in the bat species. Thank you.
For the clarity, I wanted to add, it's not that the Germans don't think that Aedes albopictus is medically relevant, but there has been none before. So there's no Anopheles, there's no Aedes aegypti. All of them are not in the list, but not because we don't think that they are relevant, but they haven't been there. That's why we started with the monitoring, because the political question was, is there tiger mosquito in Berlin? For you it might sound surprising because we don't live among the tiger mosquito. I can tell you that we had like 15 mosquitoes this year. So that's the level about which we are talking. That's why it's still not in the list. But now we can prove that we have at least 3 sites within the area of the city where there is established population. So it will be relevant. That's why we want that it comes in the list. But it's not because they didn't believe that it's relevant, but it's only now. Yeah, but it would be too easy to say yes. But for Germany or for Berlin, it's more than south-north axis. So there are some publications showing that the tiger mosquito was introduced from southern neighbors, so from Italy, from the Balkans. That's the route, probably with the loads of cargo being transported. There's a study of some colleagues 15 years ago who tested the areas along the highway, and their hypothesis was that the big trucks transporting the cargo were transporting the tiger mosquito because they found it along the highway coming from the south north. But still, Berlin until 2021 was believed to be too cold, too north. We didn't expect it to come because it's just too cold there. So when we're talking about tiger mosquito in Germany, we talk about the southern states, which border with, okay, let's say Italy, let's say Italy. There are some other countries in between, but it's not that relevant.
Yeah, it's always their fault.
Right.
Anyway, just finally,
Yeah.
listening
Okay,
to what
thank you.
Dr. Taraka also said, don't you think it's high time that Sri Lanka had a biosecurity program like the way Australia has? I mean, one that integrates everything. I mean, not the medical, because that's a very, yeah.
I think, Madam, because know that now we are up of a animal exchange, legal animal exchange. I have found several ways with the traveling with the boats. There are then that bird the detection, like the
Right.
beyond the old boats.
Okay. Any other question?
2011.
Right.
For Pakistan, that they have. Oh, that was the first time that Pakistan, that part of Pakistan, relatively, they have imported tires, old tires from both Africa, Asia, fuel for their kilns. Those tires came with eggs, and then they were kept in open yards, millions of tires. That was that then for the transmission of the 2011. Since then, now they can't import whole tires. To Lahore, Punjab, the shrapnel is allowed to be brought in. Don't import more because they understood importing these have their own risk. Coming back to Asia tiger mosquito in Japan, there was an outbreak 15.
Yeah.
That was mainly in Tokyo Park. The mosquito had been there, but somebody who had visited foreign perhaps
Came with.
I don't know where. Was
Brought the
bitten by
infection.
the mosquito, and then that mosquito started transmitting to others. Park.
Yeah.
That was that outbreak. That was published somewhere in 2015.
Yeah.
Remember correctly, excuse me. But it was that period. There was a publication about the Tokyo Park outbreak.
Yeah.
Of dengue.
Yeah. I mean,
I think Dr.
Dr.
Lucas has one more
I
point.
wanted to add, if you would be asking not about Germany but about Europe, that's the hypothesis that we have as Europe. There were old tires transported to the Balkans, and with the eggs it spread then throughout Europe. So we think about the tires as the kind of vector of bringing it to Europe, and then the cargo trucks of bringing it to Germany. And a fun fact, even the German colleagues don't know about the new ways of transmission. We found we had a report about tiger mosquito in a household through a pot for a plant, and we are now searching for the source because it might be, and if then I will publish it. There's a company in southern Germany which produce special big pots for plants. Pots? Containers?
Yeah.
And there was a guy who bought such a pot in a big store with a lot of them, brought it home, poured water in, and he had 20 tiger mosquitoes in his living room. He caught some of them, sent to us so we can confirm that it is tiger mosquito. So it's like more than we have seen till now. He had more in his living room. And we checked it. The conditions show that it's not the store. So now we are trying to check the company which produces these pots, because if this is true, then they kind of infected the whole Germany.
Yeah.
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 Banned bromeliads. Exactly the same point.
Yes.
So
Bromeliads.
Bromeliads
Yes.
are very much treasured.
Yes,
Brought
yes.
in from Thailand originally, and then grown here. So this was when you look at some of the houses where children had died way back in 2009. You realized the only culprit was those bromeliad plants. There was absolutely no other breeding place other than the bromeliad plants, which are kept inside the homes, not outside.
Yeah.
And the breeding happens within the house. That's the unfortunate situation.
Dr. Tissera, it's very well known, the horticulture industry and the aquarium trade are the two biggest culprits for introducing invasive species to Sri Lanka, right? This is not the time to talk about it, but we really need a biosecurity program. If you go to the airport around 12 o'clock in the night, where the flights from Thailand, Indonesia, blah, blah, land, and you see the custom officers, opening the suitcases, you will see plants, you will see soil, right? It's banned, it's illegal to bring soil into the country. But large cabbages, I don't understand why Sri Lankans are fascinated by cabbage. They bring them in. I mean, this is not the time to talk about this.
Right. I think the discussion is going on a very active and towards a tangent as well. But there are a lot of issues that has been brought up and very important points for the discussions to continue. And I would like to sum up the panel discussion and thanking all three speakers, Dr. Hasita Tissera and Dr. Lucas and Dr. Prasad, and also the audience for contributing to a live discussion, and my co-chair, Professor Premawansa. Like to say a few words?
I also thank all the speakers and the audience who greatly contributed. And so we had a very good interactive discussion. And I think we can conclude the session now. Thank you very much.
I kindly request the esteemed panel to stay up on stage as we are about to distribute the tokens of appreciation to the speakers of our session. I kindly invite Professor Sunil Premavansa and Professor Shiroma Handurnetti to do the honors. Ladies and gentlemen, please give a big round of applause to our speakers today, Dr. Hasita Thisera, Dr. Taraka Prasad, and Dr. Lucas Murajda. This invitation goes out to Dr. Janine Michel to come up on stage to hand over the tokens of appreciation to the chairs of this session, Professor Sunil Premavansa and Professor Shiroma Handurnetti. Thank you very much. I thank once again to all the speakers for those brilliant talks and also the chairs of this session for their contribution. Now we will be moving on to the final flash talk session where we will hear from more young researchers. First up on stage will be Chamara Amarasinghe on the title Movement Ecology, Landscape Preference and Taxonomic Structure of Pteropus medius in Sri Lanka.
Good afternoon, all professors, officials, and also dear my colleagues. I'm Chamara Amarasinghe, who was studying at IDEAnet, the program as a PhD student. And here I'm presenting my the research is about Pteropus medius. So there I investigate their roosting ecology, movement ecology, as well as taxonomic status, and again adding to the zoonotic viruses that they are hosting. So that is basically the research. And then if I'm moving to the Pteropus medius, the commonly known as Indian flying fox, and locally we call it Mavaula or Markandeya. In some part of the island it calls Markandeya. So that's one of the key species in the ecosystem, where it helps to pollinate as well as it silently expand the forest at night. So that is the ecological importance of these the Pteropus medius, as well as they carrying deadly pathogens, they carrying deadly viruses. So that's the interesting which I make to investigate on this species. And then here, so what I thought was to understand in their movement, roasting and landscape ecology is connected, and it might have a correlation with a viral spillover. So that's my research. And if I'm giving how I do that in the introductions, the sessions, so I have been fixing some GPS tracking to understand where they move, how they move, what they move, and as well as the genetic and virological the understand, adding with the taxonomic, as Professor Zaminda says, taxonomic status is one of the main key a point which we are investigating on those the areas. And also this will be aimed to conservation, the public health preparedness, and as well as their conservations. So as I said, it's a key important species in the ecosystem. Therefore, their conservation is much more important. And then my objective is, as I the said, first thing is understand their roasting ecology, movement ecology, and as well as their taxonomic status. And then finally, I'm investigating on what are the zoonotic the diseases that they can carry. So those are the main area which I focus on my other research. And then if I'm moving into the meteorology the section, I have selected 7 sites in Sri Lanka where I tagged the bats with GPS. So there are some the 2 islands, Delft and Talemana, which initially we were interested in to see whether they are crossing the country boundaries. We are interested in whether they are moving to the India. If they moved into the India, if the pathogens or virus is spreading in India, they might be the reason that they are carrying into the Sri Lanka. So that was the first interest, and then we tagged them in Trincomalee, Colombo, Badulla, Lindula and Hambantota, which is comprising the urban, semi-urban area and the higher mountain of the Sri Lanka. And then at the field, I was collecting the oral and anal swabs together with the blood and urine for the viral the extractions. And then I have collected their tissues for molecular understanding of their taxonomy, and as well as I have selected the whole 25 district to collect their skulls, because as we know, most of them are electrocuted in the light wires. So what I doing is the collecting the carcasses for analyze their skull measurements, morphological and morphometrics of the skull to understand their the taxonomy. And then those data is I have been worked on some of the statistical the modeling and the statistical analyzing, such as local convex holes, minimum convex polygons. So those are the statistical things that I am trying to understand their movement. And as well as for the taxonomy, cytochrome oxidase gene I have been amplifying for understand their the taxonomic the status. And then for virology screening, I'm doing RT-PCR and as well as ELISA testing to understand their viromes, and basically I'm working on Nipah and SARS-CoV-2 virus. This is something the interesting area, the results of the bat. As I initially said that we were thought that they might be crossing the country boundaries, and for 9 months we have been tagged them in Delft and the Mana. So far we have not found them that they moved into the cross the country boundaries. They moved into the land. The one who I tagged in Delft and Talemana, they usually moved into the country. They don't cross the borders. And then I've been tagged the 9 the roasting sites in dry zones. They have been frequently shifting their roast. Earlier we known that they might be sticking to the one location and they use as a home the roasting site. But in this tag data saying that they have been switching into the different locations, the roasting site. And when we compared with wet and intermediate zone, the bats have been roasted only 12 roasting site, whereas dry and intermediate zone bats have been used 86 roasting sites, which has a big difference. And as well as I want to say that the minimum roasting site that they have used 3, and one bat have been used with the 15 the roosting site altogether. And then in month of August, we have been tagged 4 bats in PETA. There is a colony in PETA, and then after the several days, the signal came from Victoria Dam in Digana. So I have immediately got the data and do some analysis. Statistical analysis was found in that in a one night they have been flying over 130 kilometers, taking 1 kilometer altitude. So that data is given from the Victoria Dam. That was a female one. She was fully grown female one. She was there for like 2 or 3 months having the round around the Victoria Dam. And then again, another day, the signal came from Negombo, Mutturajavela. And again, he took the flight from Mutturajavela to, from Digana to Mutturajavela at a one stretch. So this is how they moved. So this is very good, the study or the finding that we can connect into the virus spillover. So in one night, they can move many area of the island. And as well as I said, one I have been tagged in the Delft is the one who moved all around the northern area of the country, which covered 4,770 square kilometers for now. And it's about like 7.2% of the island. For 9 months, it has been covered 7.27% of the island, so which is mass moved in northern part of the country. And there is a river in Mallatuoya. We have been observed that particular one who is living in Delft and the Talemena is not crossing the Mallatuoya. Those population is always populated in the northern part of the country, whereas the other animals who populated in the southern part of the island. And then there is another the incident I have to say. So one I have captured in Lindula. Lindula is the highest, the place where we found the colony. And then I have captured one bat in Lindula. And after several days, I was getting the signal from Gampola. There is a huge colony in Gampola. It's about another good 60 kilometers from Lindula, and it moves to the Gampola colony in one night and stay there. So they use several colonies. They don't stick into the one colony. And another findings, Vihara Mahadevi Park in Colombo. So we have been observed over 4,000, 5,000 individuals, and currently we haven't found any single bats from the month of July. So we don't know where they went. So they moves. And that particular, the colony in Vihara Mahadevi Park is fully abandoned. And then what we have been observed is 98 roosts. It's about like 98%, 5% are within the water source. At least 50 kilometers away, there is a water source. They use rivers, they use lagoons, they use man-made reservoirs, and they use naturalized waterways to roost. So that is one of the key ecological or the environment factor that they shows. And then this is again one of the interesting the finding that urban bats, the Colombo bats, the average flight per night is about 4 kilometers, whereas a semi-urban, the bats fly 26 kilometers per night. So the bats who are colonized in the cities, their flight range is very short, whereas in semi-urbans, they fly far away for their ecological requirements. So that is a significant finding so far that we have gathered. And then I have been observed 2 color morph. So far I have to say 2 color morph. Northern bat is much paler and lighter, so you can see in the pictures. And the southern one who I captured in the Hambantota is much darker. So yet to be do on the molecular studies whether they are 2 different species or 1 species. So that's still pending, and we are working on that. And then for the virological analysis, have been found SARS-CoV-2, but very late positive spikes. So still we have to go for another analysis to confirm that whether they have been carrying the SARS-CoV-2. And for these, the analysis I have tried on the Nipah as well, but each and every sample Nipah was negative. And discussion and conclusion session. So this is one of the important thing that we have identified, because I have given you some unknown factors of the well-known species. We know these species very well, and some of these factors are unknown. So then investigation on this particular species, as I said, this is one of the key species in the ecosystem. So that understanding is good for the human health preparedness and as well as their conservation. And then I've been going through the lot of ecological data and the other data to understand their movement and the taxonomy and things like that. So this will be resulted at the end. The National Framework for Long-Term Monitoring and the Disease Surveillances of Sri Lanka. Thank you very much.
Next, we have Dr. Sahan Sirivardhana on the title, First Detection of Nipah Virus in Sri Lankan Bats. Dr. Sahan will join with us online.
Good afternoon. I'm Sahan Sirivardhana. I'm glad that I could join with you today to talk about my PhD project, Surveillance of Zoonotic Viruses and Viral Shedding Dynamics of Pteropus medius in Sri Lanka. Emerging infectious diseases are one of the most popular topics in the world. Even though the world has experienced several major pandemics in the history, past few decades has seen an increased occurrence of emerging infectious diseases. With the SARS-CoV-2 pandemic, people realize how easy an infectious disease can spread through the world and disrupt the day-to-day lives. Even before SARS-CoV-2, scientists have been trying to find emerging infectious diseases, especially with zoonotic origin, to have a better understanding in controlling and prevention of such diseases. Even though Sri Lanka has one of the highest fauna diversity in the region, a comprehensive surveillance of zoonotic diseases has not been done. With that in mind, IDEA project was formed. With the name implies, one of the major goals of the project was to identify emerging diseases. As the second Sri Lankan PhD student joined to the project, my focus was to do surveillance of zoonotic viruses and find viral shedding dynamics of the Sri Lankan fruit bats, mainly focusing on the flying foxes. But why bats? Starting from the first bat-associated virus outbreak of rabies in 1931, there has been several such outbreak events such as Ebola, Hendra, Nipah, and SARS-CoV. Because bats are the only flying mammals in the world, bats have developed a unique immune system that can harbor viruses without harming the individual bat. So, bats act as a reservoir species to several highly pathogenic viruses. For my project, I had two main objectives: to investigate the virome of the Pteropus medius and to analyze the virus shedding dynamics of Pteropus medius. To achieve these objectives, I collected urine samples from bats using under-roof sheet sampling from Colombo, Badulla, Anuradhapura, and Mena, which belongs to 4 climatic zones in Sri Lanka. Collected samples were stored in -80°C freezers and transferred to Robert Koch Institute for further analysis. At RKI, samples were inactivated under BSL-3 conditions, and then part of it was used for cortisol immune assays to determine the stress levels of these bats. And the other part was used to extract RNA. The extracted RNA was used for virus detection through virus-specific PCRs and metagenomic sequencing. The data generated through these methods were used for phylogenetic analysis to determine the phylogenetic relationship of the novel viruses. Along with the urine samples, monthly population counts were taken at the Colombo sampling site, and climatic data were obtained from the meteorology department for all sampling sites. From the metagenomic analysis, 17 novel viruses were discovered, including 12 species from order Piconaviralis, 2 species from family Astroviridae, 2 species from family Paramyxoviridae, 1 species from family Coronaviridae. From the phylogenetic analysis, it was found that the novel paramyxoviruses were related to subfamily Henipavirus and subfamily Pararibulovirus, and the novel coronavirus that was found belongs to genus Betacoronavirus, subgenus Norbicovirus. And the most important finding was the first detection of the Nipah virus in the country. In conclusion, through this study, the virome of Pteropus medius was described for different climatic zones in Sri Lanka. 17 novel viruses were discovered across 7 virus families, and interestingly, this was the first record of the Nipah virus in the country. When talking about the virus shedding dynamics, it was found that the viral shedding was not related to climatic conditions, but there is evidence in stress-induced viral shedding from family Piconaviralis and family Nidoviralis. Connection with the reproductive phase was evident considering the increased viral shedding during this period. Nipah virus shedding was related to the reproductive cycle, shedding only during the mating period and postpartum period. Therefore, reproductive stress could be a driver for the viral shedding in Pteropus medius bats in Sri Lanka. With that, I would like to conclude my flash talk and thank you so much.
Good morning, everyone. I'm Sarini Sepalage from the University of Colombo, and today I'll be talking about migratory birds and their importance in One Health surveillance. This presentation is based on our collaborative research between University of Colombo and the Robert Koch Institute, Germany. The One Health concept emphasizes the close connection between human, animal, and environment health. Migratory birds travel long distance across countries and continents, acting as reservoirs and carriers of various pathogens. Because of their movement patterns, they play a vital role in the global spread of diseases and therefore are key sentinels for early detection in One Health surveillance. In this study, we aim to monitor avian respiratory pathogens in migratory birds, identify novel viral agents such as C. adenoviruses, and assess gastrointestinal parasite diversity. By integrating these datasets, we hope to contribute to One Health early warning systems that detect emerging zoonotic threats. Samples were collected from migratory waterbirds across several wetland sites in Mannar Island, Sri Lanka. We collected both soap and fecal samples representing 28 different species and a total of 180 individual soap samples and 47 fecal samples. To detect respiratory viruses, we used both singleplex and multiplex PCR assays, targeting 6 major avian respiratory viruses. Illumina shotgun sequencing was used for broad viral detection, including novel agents like C. adenoviruses. For parasites, we combine traditional microscopic analysis with molecular identification using 18S rRNA sequencing using Oxford Nanopore technology. Out of the 180 samples analyzed, no positive detections were observed for influenza virus, Newcastle disease virus, foulpox virus, or avian adenovirus. However, multiple samples tested positive for infectious bronchitis virus, particularly from species such as the common red shank, Pallas's gull, brown-headed gull, bar-tailed godwit, and TEDx sandpiper. Interestingly, both infectious bronchitis virus and infectious laryngotracheitis virus were detected in the common red shank, highlighting potential co-infection events. From Illumina sequencing, we identified several C. adenovirus-like sequences in migratory species. Preliminary phylogenetic analysis suggests these may represent previously undescribed viral lineages showing links to strains reported from other parts of Asia. This finding supports the idea of long-distance viral movement via migratory flyways. Our parasitological analysis revealed a rich diversity of gastrointestinal parasites, including both protozoans and helminths. Molecular data showed high overlap between species, suggesting shared habitats and feeding behaviors contribute to parasite exchange among migratory bird populations. Together, these findings highlight how migratory birds can contribute to the movement of both viral and parasitic pathogens across borders. Integrating virology, parasitology, and ecological data allows us to better understand disease dynamics within the wildlife-livestock-human interface, the core of One Health surveillance. To conclude, migratory birds act as important sentinels for emerging infectious diseases. Our work emphasizes the need of continuous cross-disciplinary monitoring using both molecular and ecological tools. Future efforts should strengthen international collaboration to track these pathogens along global flyways. I would like to acknowledge my supervisors from the University of Colombo and Robert Koch Institute, Germany, and our field laboratory teams for their support. Thank you very much for your attention.
And with that, ladies and gentlemen, we have come to the conclusion of the third and final session of this conference today. I would like to take this opportunity to thank all the speakers and the chairs for their contribution and enlightening all of us on the topic prevention and surveillance. Ladies and gentlemen, distinguished guests, speakers, session chairs, and participants. Over these 2 days, we have celebrated achievements, shared knowledge, and strengthened partnerships. We explored a complete cycle of infectious disease preparedness, from identifying emerging agents to developing diagnostics and building surveillance systems. The IDEAnet project demonstrates what genuine partnership achieves. Training over 200 professionals, establishing 14 laboratories, making breakthrough discoveries, and building lasting capacities. Let us carry forward the spirit of collaboration, scientific excellence, and the One Health approach. I would like to take this opportunity to once again thank all the speakers and our session chairs, the participants and the organizers for their immense support and contribution to make today's event a success. On behalf of the University of Colombo and Sri Lanka, I also take this opportunity to thank Professor Andreas and his team and the Robert Koch Institute, as well as the Federal Republic of Germany for their collaboration and their immense support and the continued support throughout this entire session. Ladies and gentlemen, IDEAnet One Health Forum has now concluded, but our work will continue. Once again, thank you. Thank you for everything, and I hope all of you have a very pleasant evening. Ladies and gentlemen, I would now like to invite upon stage all of you all to capture a photograph in memory of this inauguration and in memory of this memorable event.